Recording has started and assalamu alaikum everybody. I hope you all are doing super duper well. Should we memorize the input output device working? No, you shouldn't. How long will the class be? Well, God knows, no idea. Jitna main kar saka itna hoga. So it all depends upon me and my energy level. I don't have water with me right now, so I gotta grab some water, but chalo, let's grab that at some other point. But expectedly, the class might go for like 2 to 3 hours, anywhere in between them. So I'm not fully sure how long it might go. But again, as I mentioned earlier on, it's going to be totally dependent upon me. Sir, आवाज कम आ रही है? अब आवाज सही आ रही है everybody? Kindly confirm if there is any problem at this point. Okay, you guys can see the screen and sir, piche lake this isn't lake, this is the beautiful planet Earth. I'm taking the class from the moon at this point, mashallah. But yeah, chalo, that's great. No, I'm not shouting though. It's just I brought the laptop just a bit closer to myself. So I will not be solving the Feb March paper. Sorry guys, because that's not officially announced and released. So I will not be solving it. It's against the Cambridge regulations. But let's start off and let me just turn off the chat box and inshallah, we're going to see how it proceeds. But for all those who haven't asked their friends to, yeah, I'm going to turn it off. But for all those whose friend have not yet joined, you can just quickly go and share the link with them. So yeah, you guys can just share the link with them so that they can also join in so they don't miss out. And let's start off with the course content for today. All right, assalamu alaikum everybody. The chat box has successfully been closed up and I hope you all are doing super well. So today we're going to be starting off with our discussion over the chapter number 8 programming content. In the last class, we had a pretty good discussion on what chapter number 7 is all about. We studied the theoretical concepts and those theoretical concepts were then taken into the basics of pseudocodes and the basics of algorithm making, the basics of validation, verification, how they were used and all those common sets of programming techniques you need to know to further understand chapter number 8. So for those who might not have watched that, the recording is uploaded on my YouTube channel. You can just search for Code Catalyst on YouTube and my channel will be available. Moving on, the recording for today's class will also be uploaded, inshallah. So if anybody has their paper, don't worry, the recording will be available for you all, okay? But let's start off with the paper for today. Sorry, again, paper for the course content for today. For those who might not know me, Assalamu alaikum, I'm Muhammad Maz Munir. I got a top in Pakistan distinction in computer science, and I'm currently a CS instructor, the cool CS instructor who will be guiding you all with how to master the CS, okay? And we won't be going through the normal memorization based way. We're going to explain and understand everything in great detail to see how to move alongside this. If there is anything that goes wrong, if anything goes wrong, okay, just let me wait. I did not send the link in one group. If anything goes wrong, kindly just text me on my WhatsApp number. You guys have my number, right? Just text me on my WhatsApp number so that if maybe the internet gets goes wrong or something like that, you guys can still tell me, okay? And I'm not like speaking to some random wall. But yeah, just give me 1 minute. I have to send the group. One message has been left, this and also in the past paper one. So up here and also in the past paper one. Yeah. All right, let's then just start off with the paper. Today, we're going to be understanding chapter number 8, which is all about programming. So when we talk about programming, this does not mean that, okay, we're going to learn some Python, some Java or C++ programming. It's just that, okay, we studied the basics and now those basics are basically going to be taken into some advanced manner using the concepts which are generally being used in normal high-level programming languages. Okay, so we're going to take those programming concepts which are applied in those complex languages. I'm going to bring those concepts into the world of pseudocode. So in chapter number 7, we studied how there are problems. And in chapter number 8, we're going to see that what are the perfect and the smart ways of solving those problems. So the pattern goes from problems all the way to its solution. So the very first thing you all should be aware of when talking about what do we call it? Creating a solution to a problem is, or for developing a program is, that there are basically 5 steps every programmer needs to look after when developing a program. This is something which can be tested as a theoretical question in paper number 2 too. You should be aware what are the 5 basics constructs. Like these are the building blocks, okay? So the way we make pillars, to ensure that a building does not fall or like it works perfectly fine, just like that, you have these basic constructs, which are my pillars, which allows me to create a program perfectly. What are those 5 pillars? They are basically data usage, sequence, selection, iteration, and operator usage. So data usage means that whenever I'm trying to develop a program, I need to have this thing in my mind that, okay, how will I be storing the data? It's not like, okay, if I'm making some calculation, let's say I do 2 plus 3 on a calculator. Okay, I do 2 plus 3 on a calculator. The answer is 5. Now you might see that the 5 is available in the history result too. That, okay, you did this last calculation, it's stored in the history. But have you ever wondered how is it stored? For that, your computer always makes use of some mechanisms which allows it to store data. And in your computer science course, in today's class, you're going to see how can a computer store the data in one of these 3 ways. We're going to study each of them in great detail and are going to understand what they are and how they are being used in a program. Then, secondly, while developing a program, especially like even in the 15 marker or wherever you're trying to develop a program, the sequence is really important. By sequence, I mean what are the order of the steps in a task. Like it cannot be possible, right, that when I'm writing an English essay, I write the conclusion at the start, then I write the introduction, and then I write the main body. That does not make sense, right? Likewise, when making a program, your sequence also matters a lot, where it usually starts with the step of taking an input first. Then there is some condition, or we also call this to be a process box. Okay, process. So it's input followed by process and finally some output. But the process generally is a condition based upon the example we do up here, that you always do like input age, then if age is greater than 18, output error. So we always take some input, we do some processing like maybe condition or some value calculation. Based upon that, we output something. This method which is being followed is what we call as sequence. Likewise, there is also one important pillar or construct known as selection. During computer science, when we are creating program, it's important that we need to make decisions. There are scenarios where we are like, okay, if this thing happens, do this. Otherwise, if this thing happens, do that. So when we have this case of having if and if, like if this thing becomes true, do that, else if this thing becomes true, that, where your computer needs to make a decision between two possible paths, that is something which it does through selection. So this concept where we make use of if statement or where we make use of case of statements, these are basically referred to as selection statements. Why? Because they choose a path through a program. Like if age is greater than 18, you output that, else you output child. So now your computer has like a specific path. Either it's going to take this path or it's going to take this path. So because we have these two paths right now, this basically comes under what we call as selection. Likewise, when making a program, it's really important that you also look after iteration. What's iteration? Iteration basically refers to your, just give me a minute, guys. Just a minute. Right, perfect. If anybody up here is with inappropriate names, you will be immediately removed. And let me just tell you that the moment you are removed, you are unable to join again. Okay, so you're going to be permanently banned. Likewise, when creating a program, it's also important that you look after iteration. What's iteration? Iteration is the programming word used to basically tell if something is being repeated. So generally, when we talk about loops, when we talk about for loop, repeat, while loop, and all those stuff, those basically come under a general word which is known as iteration. So iteration is the concept of repeating a sequence of steps in a program. And without this iteration, you will not be able to what do we call it, repeat a specific set of actions. And so it's really important that you always make use of iteration in your program, because without iteration, your program will be really, really inefficient. Perfect. Likewise, the fifth construct, or the most important construct while creating a program, is known as what do we call it? Is known as the operator usage. What is operator usage? Operator usage basically refers to the correct usage of mathematical formula. Like if you're doing arithmetic calculation, by arithmetic, I mean plus, minus, division, multiplication. You can make use of these actions. If you have logical or Boolean statements, you might make use of something like and, or not statements, the way we discussed it in the last chapter 7 class, that if grade is greater than 70 and grade is greater than 75, or like and grade is less than, let's say, 80, this means the person scored between 70 and 80, and that's an 8. Okay, so making use of logical arithmetics, you operators alongside iteration, selection, and sequence with the correct usage of data will get you a perfect program being created. And while solving the 15 marker, it's really important that you all understand what categories will be coming under all these steps. So your 15 marker does make use of all these steps. And if you make use of all this in the right way, you're inshallah going to get a perfect 15 by 50. Let's move on and jump into the perfect, most important discussion. The first and foremost thing when we talk about chapter 8 and when we talk about storing data is about the concept of variable. Now, variable is basically a container. It's like a box, okay? A box in which I can store data. So I can say that if I have this glass with me right now, okay, this glass, you guys can see the glass, right? This glass at this point can store some liquid. It can have some liquid inside it. So if it can have some liquid inside it, this means that if I have to basically store something inside, I can. Likewise, the data which my computer processes, in order to store that data, we have something known as a variable. A variable has this unique characteristic that it's basically a named data store that contains a value. Why did I say a named data store? Because it's not like the way I generally say that this is just a glass. No, it's not a glass. I give this a specific name. If it's a variable that can store something, it's basically going to be having some, just a minute. It's basically going to be having a specific name to it. Like it's storing, for instance, the age of some person. So I'm going to say that the name of the variable is age. So a variable is basically a named data store that can contain a value. One other important point here to note is that if let's say I have this glass in front of me, or like maybe I have this glass in front of me, it currently had strawberry juice inside. But what if I go, I wash it up and then I fill it with water? It can change its, what do we call it? Oh, just a minute. Just a minute. We just started. Okay, so the message had the word tomorrow, so maybe people are like, okay, it's today, by the way. If anybody is joining in the wrong time, the class was today. But yeah, so a variable is that type of container which can change its value during the execution of program. For instance, I gave this one example where like if let's say this is a variable x and it has the value 5 inside it, and let's say later on I might want to change the value of it, I can do it. Like this step is 100% valid that x had the value 5 originally, but then I did okay, whatever the value of x was, you add 5 into it the way we normally do totaling, right? So I just made use of the totaling concept, but you can see that originally there was this box with the name of x and it had the value 5. But after some time, the box again had the value of 5 plus 3, which was 8. So now my box has the value 8 inside it. So this value just got changed. So variable is that type of data container or that type of box which allows you to store data, but at the same time, it's also having this characteristic that its value can change during the execution of the program. But then we also have something very similar to variables, which is known as constant. What is constant? A constant is just like a data storage container, the way we talked about variable. It's a box which can have some value inside it. But then there is a problem with constant. You know what? The problem with constant is that a constant is always going to have a single value. For instance, I say that there is some sort of container which can only have, like, for instance, I have this Dettol sanitizer with me, right? This Dettol sanitizer. So right now, this has the sanitizer inside it. Will any of you be ever wishing to basically take out this sanitizer and put water inside this to drink it? No, right? No one will wish that. So we can sort of assume that this sanitizer had one sort of data inside it, and then that data cannot be changed. So it's like it's made for sanitizer. I'm going to either throw it, I'm not going to refill it at any case, right? At any cost. So anything, any data storage container which is assigned a data at the start, which can then no longer be changed afterwards, is known as a constant. So a constant is a named data store that contains a value just like a variable. It's used generally just like a variable, perfectly similar. But the only difference is that a constant cannot change its value during the execution of program. So like if I create something like constant pi 3.142, to create a constant, you write the constant keyword, then the name of the constant, and then you assign the value. We're going to study this inshallah later on too. But then I later on try to do something like pi 5.6. Now I assign 3.142 into this constant with the name of pi in the first line. Later on, if I want to update the value the way I did up here for the variable, my compiler will not allow this. They will give me an error. They will be like, okay, bro, this is not possible. Are you going to kill yourself? That's not something which I can allow you to do. And that is what we call as a constant. So remember, if a question asks you to declare a constant, you cannot change its value afterwards. And if it asks you for the difference between a variable and a constant, the only difference exists within the fact that a constant value cannot be changed, whereas a variable value can be changed during the execution of a program. During the execution. What do I mean by during? This basically means that during the program, if I do something like this and it first executes this and then comes to this won't work. But like, let's say someone might want to change the value while creating the program. Like, okay, I did this. And later on, I again open up my coding terminal where I have written all my code and I just want to erase this and I might make this like 6. Then it's fine. So I can change the value without while coding it, but it cannot be changed during the execution of a program. For all those who might have questions, what you should do is write down the questions on a blank sheet next to you, and then you all are in the computer science group. Share the questions there later on. There will be students who will help you. And then, of course, if there is any question which you still do not understand, you can, of course, tag me alongside it, and I will try my best to reply to you with that. Okay, perfectly fine. Moving on, we're going to discuss arrays, inshallah, later on, but these are two important data types which you should be aware of. Then comes up the concept of data types. So like generally, I know that there is something known as 1, 2, 3, 4, 5 numbers. Then I know that there is something like A, B, C, D, E, F, G, which is basically my alphabets, English alphabets. Then I have Alif, Be, Pe, Te, which is my Urdu alphabets. So I sort of have this one thing in my brain that when I see Alif, Be, Pe, I'm talking about Urdu. When I see something like 1, 2, 3, 4, 5, I'm talking about integer numbers. And we will not be doing 15 marker, guys. We will not be doing the 15 marker today. It's just chap 8 revision class. Okay, so and likewise, if I see something like ABC, I get to know that okay, this is English. So now that's because my brain processed all of these things separately. My brain knows that. For a computer to understand the difference between ABC, 1, 2, 3, maybe true, false, and all that stuff, it needs to have some data types. Like the way I say this is English, or I say that this is, let's say, Urdu, or this is integer numbers, your computer needs to be told what the different type of characters and values are. So your computer basically processes 5 types of data. The first one is known as an integer. It's the same integer you studied in your maths, which is basically any whole number. So the main point up here for an integer is that it needs to be a whole number. Anything like 3.2, 3.3, this is not an integer. Why? Because it's not a whole number. Anything which is a whole number like 1, 2, 3, it's basically an integer. And on an integer, you can basically do multiplication, plus, minus, divide, and all that stuff with any integer value. Likewise, we have the second data type, which is real. Real is just like an integer, but it's like a numerical value with a fractional part. When I talk about fractional part, this basically means that it has a decimal point with it. So it has a decimal point with it, DP. So like something like 4.5. So this 4.5 is basically a fractional part. And I even discussed this up here with an example that let's say there is 3 plus 1 by 2. So this 1 by 2 is a fractional part. But when I add it, I get something like 3.5. So when the computer wants to process something like a point inside it, 3.5, 4.0, 3.97, such data type is basically known as real. And again, with real, you can do plus, minus, you can even do multiplication, you can even do division, all the steps, okay? Then comes the data type of string. What's a string? A string is basically that type of data type, which is basically a variable, which could be a variable or a constant that is basically several characters in one. So like if I want to store some characters like M is a character, A is a character, A is a character, and Z, my name Mars. So if my computer needs to process this entire statement, this will be basically stored as a string. So my computer would be like, okay, this is not a sentence the way we normally say that it's a sentence. We say it's a string. It's a string value. And remember, a string value is always surrounded with double quotation marks. This double is really important. If anyone does something like this, Mars, but with a single quotation, you're going to get it 0 marks. Remember, whenever you want to make store of double, what do we call it, string, it always has to be in double quotation. keep this in your mind. So when you have a string is basically a variable or a constant that is several characters in there. Or in other words, I can say that there are multiple characters which are joined together. So I might have M is one character, A, Z, C, S, 1, 2, 3. So all of these are separate characters. And if I join all of them and I make sort of one sentence out of them, it's going to be a string. But to denote and tell the computer that it's a string, I need to basically put it in a double quotation mark. Now, when it's in a double quotation mark, my computer will understand that, okay, this person is talking about a string. The way we have English rules, right? The way we normally have English rules. Similarly, when you put something in double quotation marks, it's a rule for the computer to understand that, okay, this person is talking about a string value. Likewise, in some occasions, there also is a possibility that we don't have to join multiple characters. We are just good to go with a single character. Like, for instance, a question asks that, okay, tell us about your gender. So M for male, F for female. So if a person has to enter only M, or they might only enter something like F, M or F, one of the two, your computer does not need it to be a whole string. Why? Because it's only one character being inputted. So when a computer wants to process only a single character, that is something denoted by a character. Car, char. They have multiple pronunciation, but it's generally denoted as car. Okay, character. And when you want to represent a character or a variable which has just a single character as a value, like let's say a gender having the value of, let's say, female, F. So you cannot directly write F. The way for the string, we did double quotation marks, right? For a character, we always do a single quotation marks. Again, remember, if it's a character and you do something like this, and it was a character, you're going to get 0 marks. So the main point here to understand is that when you want to represent something as a character, it has to be done with single quotation marks. When you have to do something with just a minute, guys. Bad mobile. Yeah, sorry for that. My friend was calling. Let me just tell him I have a class. All right, let's move back on to the content. So yeah, the main point here to understand is that the next time the question asks you regarding a character, please don't make this mistake of having double quotation marks. And when they ask you for a string, please don't put single quotation mark. This is something which costed me marks in my A-level exam. I don't want you guys to miss upon this. Okay, so just like that, we have the last data type, which is known as Boolean. A Boolean is basically that type of data type which allows a variable or constant to have only two values. So like if I have a scenario where I only need to have two values, maybe true, false, yes, no, on, off, male, female, let's say good, bad. Whenever there is a scenario where you are only going to have two values, like character or string could have multiple values, right? Yes, no, maybe, however, blah, 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 blue, blah, 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 and everything, right? A Boolean is that data type where if a variable or a constant needs to only have two possible values, only two, either true or false, then that, or like yes or no, on or off, like only two values, such a data type, whenever I want to tell the computer that, bro, this is something which is only going to have two possible values, that is something which will have the data type of Boolean. And I hope this is also clear. Moving on, these data types are really important because when we create a variable and a constant, we need to specify the specific sort of, yes, we will be putting an end to pseudocode today, inshallah. So generally, when we basically talk about these data types, it's important because when we are creating a variable or a constant, we tell the computer what's the data type of it so that it could accordingly behave. So when we start discussing the topic of declaration, these data types are really important because how do you declare a variable? So what's the purpose of declaration? The purpose of declaration is to tell the computer that there is this specific variable which is going to store a value of this type. So for instance, I might have a notebook in front of me. The notebook will have written, right, that this is a computer science notebook. So like for somebody else who might want to open it up, or even for me when I want to open my bag and bring out my notebooks, I can see that when it's computer science written on it, I can see that, okay, it's going to have CS notes inside it. It's going to have CS practice inside it. So just like that, whenever I want to create a variable which is going to store data, my computer needs to be aware of what's its data type going to be. For that, we always declare it. And how do you declare a variable? You write the keyword declare, Followed by that, you write the name of the variable, you put a colon, and then you specify the data type. For instance, an example was that if I want to create a variable with the name of sum, a sum is always going to be storing integer values, right? If I might want to do something like 2 plus 5, the answer is 7. So 7 is an integer. So I need to create a variable with the sum, which has the data type integer. So I will be doing declare, followed by the name of the variable, which is sum, colon, and integer data type. Okay, and once you always declare a variable, it's important that you also initialize it. Initializing basically refers to assigning it a value at the start of the program. So whenever you have a program, you need to assign it some value at the start. Okay, you need to assign it some value at the start. Usually, when you create those programs, that value generally starts off with 0. Like if I want to create a program that calculates the sum of all your papers, of the papers you all solved, let's say. So generally, when I start writing the code at the very start, the variable sum needs to have the value 0, right? Like for instance, if I want to start counting, the counting always begins from 0. But your computer doesn't know that counting begins from 0. You need to tell the computer that, okay, counting has to start from 0. That is why at the start of the program, wherever we have sum, count, anything, we initialize it with 0 to tell the program, to tell the computer that we are starting from 0. Like generally, we take this assumption that if I have one student score 20, so I'll be like, okay, the sum of the first student score in that sum variable is going to be 0 plus 20. But if you never tell the computer that sum has the value 0 inside it, your computer will never know that it's starting with 0. It might have some random value like 5 billion, 5,000. 100, negative 300. So it's important that whenever you create a variable, you always assign it a 0 value at the start, or you assign it some value, which we call as initializing. Moving on, if you might want to create a constant is basically created by writing the constant keyword. Then you write the name of the constant and you put an equals to sign and write the value next to it. So you don't do anything like declare, you don't put a colon, you don't specify the data type. You just write the keyword constant to indicate that, okay, it's going to be a constant with the name of pi, and this will be having the data of 3.14. So now this will ensure that a pi constant is created and that will be having the value of 3.142. Okay, that's how you create. For a lot of people who might also declare constants the way we generally declare a variable, you're going to lose marks. So please don't do that mistake. Always declare a constant a different way, generally through this keyword constant. Okay, so this is really important. Moving on, it's important to understand that while we have understood all these data types, in your computer science paper, generally questions will be coming up, some complex sort of questions that will ask you to basically manipulate, or by manipulate, I basically means that maybe do something with strings. So maybe I might say that you need to grab some character from a string, maybe apart from the string, maybe the length of a string, maybe something is in lowercase, make it uppercase. And for that, the thing is, you might be wondering that, sir, examiner wants to kill me. But no, examiner is there to support you. Examiner is like, okay, you don't need to do those complex calculations. I am a very good friend of yours. I have created pre-built functions for you, which you just need to memorize. And this will basically allow you to basically ensure that if you might want to make use of, what do we call it? You're going to have pre-built function, which if you might want to manipulate the strings, you can using those functions. Okay, so we have, guys, just a minute. Guys, chill. Please don't send me messages on WhatsApp. I won't be answering those, please. It's not like a chat box for you all to just spam me with questions. But yeah, we have those. Let me just put my phone to silent. So we're going to have these pre-built functions, and these pre-built functions are basically used for string handling. This concept which we're going to study is known as string handling. What is string handling? It's basically the functions. These are the functions which allow you to change the value of a string. Okay, so there might be some string and they might ask you to basically modify its value somehow. So that is being done using a string. So we have a really good question, by the way, that if this constant, generally when we assign a value, we put an arrow, right? We do something like some arrow 0. Do we also put an arrow up here? No. When you create a constant needs to have an equals to sign. It does not need to have an arrow. So it's going to be having equals to value. Okay, so don't be like constant name assign value. No, you put an equals to when you're creating a constant. That's an exception. So To start studying the string handling functions, the first four functions which you're going to study, these are all pre-built functions, which means that you're just going to use the name of it. You are not required to know the code of it, right? You're just going to use it. You're just going to call it. You're not required to know how it works and all that stuff. You just need to understand where to use it and how to use it. So the first four functions which you're going to study, those are going to be related to string handling, which means it could be used on all the strings. And then the later on could be used on numerical values like integers too. The first one is length. For instance, someone inputs something like their name. So input their name. And I want to see what's the length of this name. How will I do this? So for that, the computer science instructors, they provided us with a length function, which returns or basically tells the user how many characters are there in a specific string. For instance, this is what we also call as a length check. In chapter 7, we had a validation for this. And the way we do is that we, let's say, have a variable which has been declared with the name of name, having the data type string. And let's say there is a variable length name with the value of integer. Okay, we declared it. And then I input a name and I want to see how many characters are inside there. So I'm going to just write the keyword length. And in that, I'm going to pass this name as a parameter. And by parameter, I mean like the input. So like I would be like, okay, go in this length function, put the value of the name. And then this length function is going to do some magic. And it's basically going to count how many variables, characters are in the variable. And it's going to store that in the length name. And that's going to be outputted. So for instance, I do something like Mars, which is a string. It's going to count 1, 2, 3, 4. So my len name is going to have the value of 4. So when I output it, it's going to output the value 4. But now if anybody puts some number up here, like generally there is a question where like they say that you need to ensure that this number 1, 2, 3, 4 is of 4 digits. If someone does something like length 4, 5, 6 or 1, 2, 3, 4, but it's not a string. If it's not a string, if it's something like integer, it's going to be incorrect. It will not process it. It's going to give you some error. Why? Because this length function is only going to work upon strings. This is also really important for you all to understand. Just like that, the second function is basically known as the uppercase function. Uppercase function is the one where if let's say I have written something like Mars, and I might want to convert it into capital M-A-A-Z. How will I do this? I'm going to make use of this function, which is known as uCase. So uCase variable works in a way that you write the uCase and then you specify what value do you want to make into uppercase. So for instance, I inputted some sentence and I want that this sentence should be totally in upper one. Like even if it's something like M-A-A-Z, M-U-N-I-R, mixture of upper and lower, but I want to convert all of them into capital one. Like for instance, for some example, where I might want to see that, okay, you need to input a variable X. You need to input the value X. Like let's say the program will end when you input the variable X. The value X, okay, the value X. So a person can enter lowercase x and they can also enter uppercase X. So that's a problem, right? They might enter lowercase and uppercase. So to ensure that whatever the user inputs, I'll be like, okay, whatever the input of the user is, make it upper one. So even if it's lower one, or like let's change it to like input. So whatever the input of the user is, even if the person inputs lowercase x, it's going to become capital one. And if it's capital one, it's still going to stay capital one. So in cases like this, where we might need to change the lowercase one into uppercase one to ensure that it deals with all possible values, we make use of the uCase statement. And in those exams, a lot of times they just say that, okay, you need to convert all of the variables into uppercase form. So how do you do that? You're like, okay, you make use of uCase function. Then in the parameter, you assign the variable which you need to convert. And then this is basically going to assign you some value. And that value will then be stored in upper sentence variable. So if someone just does something like this, uCase sentence, or any of these functions just like this, that's wrong. This is a function. A function always returns a value. You're going to study that, inshallah, afterwards too. But because it returns a value, I'm going to say that it's going to be assigned to a specific variable too. Clear? Moving on, just like uppercase, if I have to basically convert capital letters into lowercase one, I can do that using the lcase command function, where if you do something like lcase capital hello, it's going to convert it into lowercase hello. So for example, here is an example code that let's say you input something like a paragraph and you might want to convert this into lowercase one. So we say lcase paragraph, and this is basically going to convert that capital hello into basically lowercase hello. And that's then going to be stored in updated one. Now when I do output updated, it's going to print lowercase hello for me. And the fourth string handling function, which is there in our syllabus, is known as substring. What substring? Substring is basically that specific type of function which basically allows you to grab a part of string. So like, for instance, if I have a whole Mars Munir as my name, okay, and I just want to grab Mars part out of it, and I want to ignore the Munir, like I'm saying that, okay, bro, in this entire string, grab the Mars part out of it. How will I do that? So to grab a part of a sentence or a part of a string, we have a function known as substring, which has this syntax or logic where you say like substring is the name of the function, then you specify the name of the variable, then you tell what point do you want to start with, and then you say that from that point, how many characters do I need to extract? For instance, in this computer science example, I want to grab this science out of it. So how will I do that? So I would be like, okay, there is a variable with the name of, let's say, CS. Okay, there is a variable with the name of CS. So I'd be like, okay, go to the use the substring function on the variable CS, which has the value computer science. In that, go to position number 10. What's position number 10? So this is position 1, position 2, position 3, position 4, 5, 6, 7, 8, 9, position 10. So go to this position 10, which is starting from S. And from there, you need to grab 7 characters. 7 characters. So one this, including 1, 2, 3, 4, 5, 6, 7. So starting from the first position, it's going to grab these 7 characters. It's going to put it up here. So it's going to come up as SCIENCE. So you just saw what happened was we basically modified the value in a way that we created a function that basically grabbed a part of a whole string. And the general logic for it is that, let's say you might want to take a part of a subject, right? Like, for example, now I want to grab this computer part. So I would be taking an input, and then I would be like, okay, I want to store this one part, the first part, in the variable first part. And I'm going to make use of substring function, which is being applied on the subject name variable, which is this, and go to position number 1 where you need to start. And then from position number 1, count 8 characters, 1, 2, 3, 4, 5, 6, 7, 8, and grab all this and put it in the first part. Now, when I do something like output first part, it's going to bring up computer on my screen. And that is how you basically make use of substring in your exam. So if ever in exam they ask you to, let's say, compare each character one by one, like let's say you need to compare C, then you need to compare O, then you need to compare M. The proper way of doing it is that, like, let's say I want to do it for here. I'd be like, okay, if, like, for instance, I want to find the @ sign. Is there any @ sign up here in this example or not? So to do that, I would be like, okay, if substring, let's say the name of the variable is CS, go to position number 1 and grab one character. So go to position number 1 and from there grab just one character. So this is going to grab the variable C and compare it. If this is equal to @ sign, this means there is an @ sign. If not, you can then move on to the next one. How can I move on to next one? So I can make use of this example. Let me even do this for you all. Let me do one example for you all up here. So for instance, I want to go through my name Mars to see if there is any sign like @ inside it or not. So the way I'm going to do it, I'm going to make use of a for loop. I would be like, okay, for count, start from the position 1 all the way to whatever the length of my name is. Okay, whatever the length of my name is. And what I need you to do is you need to check that if substring variable name is name, go to the position number where I'm starting off, which is count. Go to whatever the count position, like originally it's going to be 1, right? And from that position, grab one character and compare that with @ sign. If it is equal, okay, it just got off, but if it is equal, then you might say output found. If it's not equal, in that case, you might just increase the count value. So if it was originally doing something like, where did it go? If it was something doing like substring 10, 1, now when I do count plus plus, when the count increases, it's basically going to go to 11, 1. So now it's going to grab the 11th character and it's going to check that. Then it's going to go to 12, 1, it's going to check that. Then 13, 1, check that. 14, 1, check that. 15th one, check that. And so on, it's going to go on. Clear? That is how you make use of substring even in those advanced questions. Moving on, these are some examples. You can check out these later on my website. The recording has, the notes have already been uploaded. So you can review the notes later on too, and it can help you understand it really well. Moving on, now we have some library routines. Now, library routines are those specific type of functions which again examiner introduced for your ease, for your feasibility. But this is something which is being used on numerical values, like integer values, like real values, something which are generally mathematical values. And the first one is known as div. What's div? Div is that function which allows you to divide a number by a value and it returns the quotient. What's a quotient? Quotient is like, let's say you want to divide 24 by 5. We do it this way, right? Like 5 fours are 20. This 4 is my remainder, and this 4 up here is my quotient. So it's important for you to understand that in a lot of programs, we are required to find this 4 and this 4, like the remainder one and the quotient. So there is a shortcut to, rather than doing this, the computer programmer, they made a function with the name of div, which basically tells me the quotient. So how do you make use of div? You just write the number or the variable, and then you, using a comma, specify what value do you want to divide it. Like for instance, 24 comma 5 with a div basically means that divide 24 with 5, and whatever the quotient is, which is this upper part, give me that answer. So if I do div 24 by 5, the answer is going to be 4. Why? Because my quotient is 4. So for instance, I might want to store the answer. So it's basically declare quotient integer. In quotient, store the div 24 5. Now I might want to output quotient. It's going to give me the answer of 4. And likewise, in some cases, I might also require and have this ideology about how to calculate the remainder. So again, you might be thinking that that's going to be complex, but no. If you want to compute the remainder somehow, just the way we have div as a function, we also have a mod as a function. So a mod is the second library routine which we are studying that basically returns the remainder of a specific value being divided by number. For instance, I might do something like 17 divided by 7. So 17 by 7, basically when you do 2, it's 14. So my remainder is 3 and my quotient is 2. So now if I do something like mod 17 7, the answer is going to be 3. Why? Because 3 is my remainder. So this mod function basically provides me the remainder. And if I do something like div 17 7, div 17 7 is basically going to give me the 2. Why? Because that's my quotient. That's my quotient. So when I make use of div function, it returns me the quotient. And when I do something like remainder, it's going to return me, mod, it's going to return me the, what do we call it? Remainder value. So these are really important functions which you should be aware of. Moving on, the third one is the known as round. Now, what's round? Like for instance, I have something like 1.6789, which is like a decimal number, and I need to convert this into 2 decimal points. How will I round it off? So to round it off, we have a function with the name of round, which is basically used with this specific what do we call it, logic, where you write the variable or the value up here and then you specify the precision next. So you're like, okay, round 102.578 comma 2, which means that you round the variable value 102.578 to 2 decimal. So like if there is something like 35.894 and I round it off to 1 decimal point, this is basically going to become 35.9. And if I do something like round 102.578 comma 0, this means that you go to 0 decimal. What do I mean by 0 decimal point? It means that if there is no decimal point, this means you convert it into a whole number. So it's going to become as 103 because this is going to round it up. I don't need any decimal points at all. So if whenever I want to convert something to whole number, I always want to round it to 0 decimal. This is something a lot of people are not even aware of. But just like that, if you might want to make use of round function like the way we did it with a value here, you might want to do it with a variable. You can also do that, like num being assigned with the value of round, the variable, and then 3. So now whatever the variable value of round number is, let's say num is something like 4.7289. It's going to convert that to 3 decimal points. So 4.729. That's the function of your round function. Perfect. Moving on, we now have a function which is known as rand. And this is that function which a lot of people generally mess up. It's that function which a lot of people usually mix up. It's that function for which a lot of people don't know the correct logic. What's a random function? A random function is a function which generates a random value between 0 and 1. So it does not generate a value either 0 or 1. It generates a value between 0 and 1, which means it can generate 0.1, 0.2, 0.3, 0.4, and so on, 0.95, 0.99, and so on. It can generate any random value between 0 and 1. So when you're trying to generate a random value between 0 and 1, you're just going to write result, which might be some variable. And in that, you assign the value of random with these brackets. These brackets are necessary because they indicate that it's a function. So what's going to happen? This will basically generate a random value between 0 and 1. But then there are two ways of basically generating. What if a question comes up and they say that, okay, you need to generate a value between 0 and 50. Now, there are two ways to doing this. One is the one which normally teachers tell, which is also something used in A levels, where you do something like random. And in that random, you assign it a value like 0, 50. But according to your syllabus, according to IGCSE syllabus, according to O-level syllabus, this method is not valid. For you all, it's a bit complex. It's a bit different. The way you all are required to make use of random function is that we all know random makes a random value between 0 and 1. So it could be 0 0.1, 0 0.2, 0 0.5, 0 0.9, or so on, right? So, and also if anybody of you have a question that what if I might use of random 0, 50, will I get marks? Maybe you do not get marks. Okay, so it's better to use the one which I'm just telling. So how are you going to generate a random value between 0 and 50? So the correct way of doing that is I'm going to make a random function which is going to generate a value between 0 and 1. And then you need to multiply that value with 50. Multiply that value by 50. Why are you going to multiply that with 50? Because let's say there is a value, let's say it generates 0.5. This part generates 0.5. This part generates 0.5. If this part generates 0.5, I multiply 0.5 with 50, I get the answer as 25. So boom, I got a random value generated as 25. Just like that, it might generate something like 0.8. 0.8, when I multiply that with 50, if I grab my calculator, it's going to be 50 into 0.8, it's 40. So now it's generating a random value like 40. Let's say it generates a random value like 0.767. Now it might generate something like 0.767 into 50. It's going to give me like 38.35. But now for the first two, it's fine. But now I have a decimal number generated. I don't want a decimal number, right? I don't want a decimal number. I want a whole number. So this means that if there is a possibility for a decimal number to be generated, I'm going to round this off to whole number 2. So for that reason, whenever you would have seen in marking schemes and all those places, when they generate a random value like this, they also round it off. So they round the random value so that if anywhere something like this comes up, like 38.35, you round the answer of this to 0 decimal. So now if the same 38.35 is generated, it's going to round it off to 38. And that's how you generally round off a whole value while generating a random value between 0 and 50. Now, one other question a lot of you might have in their brain is that, sir, what's the largest? And like, for instance, let me take one other case. Like, for instance, what's the smallest value random can generate? What's the smallest value random can generate? It's a 0, right? Because the smallest it could generate is a 0, and the largest it could generate is a 1. And in between, it could generate multiple values. So if it could generate something like a 0, 0 multiplied by 50 is a 0. So it can generate a small value of 0. And likewise, what's the largest it could generate? It's 1. So 1 into 50 is 50. So the largest it could generate is a 50, which makes it perfectly fine that it can generate a value between 0 and 50 the way we want it. But what if a question comes up where you might want to now generate a value between 1 and 50? So now for 1 and 50, this becomes a bit complex. You know why? Because I know that it's going to generate a value between 0 and 50. So what I can do is, let's say I'm going to do the exact same thing, but if it generates a value of 0, I'm going to add 1 into it. So if it generates a value of 0, add 1 into it so that if it generates 0, it should give the answer of 1. What's the smallest value up here? It's 0, right? 0 is the smallest value. So if I add 1 into it, this means that the largest value it could basically produce is a 1. So if it could generate something like a 1 in this case, so the largest value it could generate is basically a 0, a smallest maybe. So if the smallest value generated is a 0, this means I can basically generate a value greater than that. Maybe I might do 0 plus 1. So like if the smallest this could generate is a 0 and I add 1 into whatever the answer is, this means now the smallest value is going to be 1, right? Because if it's something like 0.1, which is the second smallest value, and I add 1 into it, now my second smallest value is a 1.1, and my smallest value is a 1. That's clear, right? But likewise, you might have this one question that, sir, then the largest value is going to become like 50 plus 1, which is going to make it 51. But I want the value between 1 and 50. So if you want to generate a value between 1 and 50, it's basically done likewise, just the same thing is repeated. You do round, you calculate a random value. But the way we just saw that, because there is a possibility for it to generate a value between 0 and 50, where when I add 1 into it externally, it can cause it to become 51, right? It can become 51. So what we can do is we can create a value till 49. We can create a value till 49. And then if it like maximum generates something like a 49, which is the largest possible value, once this has been done, I'm going to add 1 into it. Now, the smallest this round function up here can generate is that the smallest value this could generate is a 0. And 0 plus 1 is 1. So my smallest value comes out to be as 1. And then the largest this could basically produce is a 49. And a 49 plus 1 is basically a 50. So now you can see that it generated a random value between 1 and 50. And let's say it generates something like 0.1. So that might be something like 4.9. So 4.9 when rounded off will become 5. 5 plus 1 will be 6. And so I generated a random value like 6. And for all those who might have a question that, sir, what if a question comes up to generate a random value between 20 and 50? There will be no questions like this. Like at least even if it does, there is no other way you need to make use of your brain. But I haven't seen any question like that. And the maximum they test you upon is like 0 to something or like 1 to something. So that is how you generally do it using a random function. And I hope now you guys are aware as to why we make use of random, multiplied with a number, rounded off, add a 1 or not add 1. That's the logic behind what's happening. So if there is any question, you can just write that down with you and we can discuss this later on because we have a lot of course content to cover. So we're going to just move on. Okay, let's move on to now the next and the most important concept of your chapter number 8, or perhaps the most important topic of paper number 2, which is basically arrays. After this arrays topic, we're going to take a small break of 5 minutes just so that you all can drink water and then we are going to restart. Okay, so what's arrays? Remember the way we generally talked about variables, constants, arrays is also pretty much same. It stores data. But arrays have one extra feature. Okay, arrays have one extra feature. First thing to understand is that arrays are of two types. One is known as the 1D array, the other is known as the 2D array. What's the difference between them? The 1D array is basically of one dimension, the 2D array is of two dimension. At this point, I'm pretty sure a lot of you would be aware of the difference between what 1D and 2D is, but still we're going to understand that in great detail, inshallah. But now, why do we have arrays? That's the question which you all should be asking. So let's say I have a scenario where I ask everyone to store the marks of 5 students separately. So how will you store the marks of 5 students separately? You're going to create 5 separate variables, right? You might be like student 1 marks, student 2 marks, student 3 marks, student 4 marks, student 5 marks. You're going to store the marks of all the variables and you're going to assign them marks. But what if I say that there are 150 students in a class? 150 students. Now for 150 students, will you create 150 separate variables? Well, you can, but that's very much inefficient. That is something which we don't want, which we don't like, because it's just going to waste. Like, why the hell will I be declaring 150 separate variables? So what computer scientists did were, they were like, okay, why not create a model where rather than creating separate variables, we can create one container that could have 150 smaller parts. For instance, rather than creating one shelf for every student, what we can do is we can create one shelf, but in that one shelf, we can have multiple parts. So every student could have their own respective student number 1, student number 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, rather than creating 12 different shelves, we created one shelf that could store all of the 12 students' values. And that is what we call as an array. An array is sort of a container which stores values but is grouped under a single name. For instance, I have to store all these things separately: books, toys, games, clothes, and controllers. And I, rather than storing them like in my room, I have this one place. So let's say this is a wall. And in that wall, one way is that I store books here, games here, toys here, clothes here. I'm wasting a lot of space for no reason. So what I can do is I can create one sort of big, what do we call it? What do we call it? Now मेरे ज़हन से भूल गया. Shelf. So we're going to create a big shelf, and in that shelf we can store the stuff like, okay, at the bottom I can store books, then toys, controllers, clothes, and games. And I can tell everybody that this shelf has the name of Bachpan. So now if I want to take something from the shelf, I will not be like, okay, let me search in the entire room. I would be like, okay, and I don't need to create 5 different rooms to store all that stuff. I'd be like, okay, there is a shelf with the name of Bachpan, and in that Bachpan shelf, there are my 5 different type of items stored, and I can take everything from. Just like that, if I might want to do the same thing for the students, I can basically, rather than creating separate variables, I can create sort of a shelf. And this shelf is what we call as a row, an array, where what we can do is we can store the marks of all the students up here. I could be like, okay, student 1 marks are stored up here, student 2 marks are stored up here, student 3 marks are stored up here, student 4 marks are stored up here, student 5 marks are stored up here. Now, this thing is given one name. I will not be like, okay, go to student 5 marks. Perhaps I would be like, okay, there is going to be a name of an array using which I can go to student 5 marks position. How will I do that? Let's discuss that. So, how do you create an array? So to create an array, you need to first and foremost understand how do you declare it. So whenever you're creating an array, you should always be aware of what's the starting point and you should be aware of what's the ending point. So like it's the same way, if I'm creating a shelf, I should be aware how many rows do I need. Do I need 6 rows? Do I need 5 rows? Like 1, 2, 3, 4, 5. This is a row. Okay, this one thing is a row. How many rows do I have? So based upon those rows, I'm going to declare an array. And then I'm going to specify that what's the data type of it. Remember, an array will always store data of one type. So like it's either going to have marks or it's going to have sentences like A, B, C, B, L, A, and blah, blah. Or it's going to have characters like A, C, D, F, and so on. It cannot be possible that one row is integer and the next one is like an ABC. That's wrong. An array is always going to store data of one type, and that's the reason why when you declare an array, you need to specify the data type. For example, an example for you all to, let's say, create an array which can store the marks of 50 students will be how you're going to write the name of declare, then you're going to write the name of the array, like you see declare followed by name of the array, then you need to put a colon. Usually after the colon, we just write the name, right? Like the integer or whatever. For an array, we need to tell the program that the computer that, okay, I'm creating an array. So you're going to write array keyword the way we did up here. Then you're going to list the starting point where you'll be like, okay, if I'm creating a shelf, the smallest one should be 1. Like it should start from position number 1 and it should go maximum till position number 50. So I'd be like, okay, go with array, start with position number 1 and go to the ending, which is going to be at position number 50. And you should create this array, which is going to store integer values in between. So this is basically going to create something like this specific sort of an array, which is going to be empty. And this, because it has only one column inside it, just one column, we call this a 1D array because it's of one dimension. And because it's of one dimension, we say that this has to be a 1D array. Now, when we have something like this generated, you need to now understand that how will I be accessing the array? I'm going to grab the data inside them. I'm going to manipulate them. So remember, you always access the array in a way where you write the name of the array and then you tell them what position do you want to go to. So like I know that every row up here has a position 1, 2, 3, 4, 5. If I, let's say, want to go to the position number 1 value, I would be like, okay, let me write the name of the array. So like, let's say the name of this array is student mark. I'm going to write the name of the array student mark, and then I'm going to write the position number of it. So now if I do something like X variable, and in that variable, put the value of student mark, but go to position number 2. What this means is that basically you need to go to the array with the name of student mark, which is this student mark. And in this, you need to basically go to the position number 2. And in that position number 2, whatever the value is stored, you bring that value and you put it in the variable X. So we have a student mark array. We go to that array, we go to position number 2, and we grab this stuff out of it. So now if I want to access the data at position number 5, how will I do that? I would be like, okay, student mark go to position number 5. So it's going to go to this array of student mark. It's going to go to the position number 5. It's going to see where's the position number 5, position 1, position 2, position 3, position 4, position 5. Okay, I got this data. This thing is basically then converted into the value 45. And now if I assign it to some variable like x, this 45 will be then placed in the x variable. That's how you access an array. So now, if I want to, let's say, change that value, like for instance, I want to assign the position 3 value to a variable. How will I do it? I would be like, okay, there is a variable with the answer. In that, you need to put the or assign the data of the array scores, but at position number 3. So now you go to the scores array, you go to position number 3, and whatever the value is inside this, you take that and you put it in the answer variable. So now if I do something like output answer, it's basically going to be 90. But now the best part is that I'm no longer required to create 5 different variables to store the marks of student 1, marks 2, marks 3, marks 4, marks 5 marks. Rather, I just created one array and now I'm like, okay, scores, but with 1 basically means student 1 marks, scores, but with 2 basically means student 2 marks, and so on, right? And likewise, if I, let's say, want to change the value up here, like I might say that I want to change the value of the position number 1 of 60 with 30. How will I do that? So I'm just going to write that in the scores 1 position, like go to the array scores, add position number 1, put the value of 30. So now it's going to go to the scores array, go to the position number 1, and up there it's going to store the 30 value inside. So that's how you basically change a value of an array, okay, or how you assign a value to an array. Is this clear, everybody? Now we are going to see how do you fill an array. Let's say we created an empty array, and there is nothing inside it. Okay, there is nothing inside it. This is an empty array, it has nothing inside it. If I want to fill this with data, one way is that I separately do that. Okay, marks position 1 is 70, marks position 2 is 50, marks position 3 is like 30, and so on. You fill it up. But that's pretty inefficient, right? Because you are sort of just going again and again doing the same thing, which was similar to the variables we are declaring. So what we can do is we can make use of a for loop. You will be like, okay, bro, we're going to make use of for loop, and you'll be saying that for the loop starting from position 1 all the way to 50, this is basically the starting position of the array, and this is basically the ending position of the array. For all these positions, you're going to input the marks, and you'll be like, okay, go to the marks array, whatever the position is, like at the start, it's going to be 1, put the marks there. So it's going to create an array. It's going to go to position 1. It's going to put the input. Let's say I input 30. So 30. Then it's going to go back. Now the count value will be 2. Again, I'm going to input something like 50. So now 50 will be basically placed in marks position number 2. So it's going to go to position number 2 this time, and it's going to put that 50 up here. And likewise, it's going to go for all of the 50 elements. And at the end, you're going to see that my entire array will be having the values. And all of this will be incrementing automatically and will be done automatically thanks to the for loop and the next count. So in exam, especially in the 15 markers, sometimes a question asks students to initialize a array with 0 value. Or like I did a 15 marker that day, which said that initialize the array with an empty string. So how will I do that? So it's just like for count 1 to 50. I'll be like, okay, go to the marks array, whatever the position is, put a 0 inside it. So it's going to go to the marks array, whatever the position is based upon the value up here, it's going to put a 0 inside. And then it's going to go to the next. And just like this, one by one, it's going to basically modify the entire array, and your entire array will be then filled with data. Just like that, if ever in exam previously, like when I was preparing for my exam, right now we don't get such questions a lot. But if ever in exam there is a question which does not specify how big of an array do you need to create, how big of an array you need to create, and they don't tell you what's the size of an array, and you are required to still create the array, then always try to create an array of very big size. So maybe a question says that you need to create an array which stores the marks of the student, but you're not aware how many students there might be. So just create an array of, let's say, 500 elements, something very big. But this is only if the question does not specify the array size. I've seen the 2025 papers, and according to all the latest papers, they do specify the array size. So this is very much irrelevant at this point, but ever just be aware that if a question never specifies, don't be like, okay, ab main kya karunga? Am I cooked? No, you aren't cooked. You need to just create an array size of something very big. So you need to assume that the maximum number of elements are like maybe 100 or maybe 500, or just create anything which basically tells the program, the examiner, that, okay, you created an array which can accommodate a large number of elements. Okay, and likewise, if I now have an array filled up with data, like the way I have up here, that there is an array with the name of names like Maz, Musa, Mustafa, Hamza, Alina, Maria, and I might like want to output the data. How will I output the data? So, like, let's say there is this names array which is being declared this way. Now, this is just to tell you how to declare it. It's not relevant up here, okay? If you're outputting something, this means it is already declared, but this was just to tell the students how to declare an array. And now, if you have an array like this and you want to output it up, the way you're going to do is it's similar to the follow, the input one. You're going to just go from position 1 to 6, and every time you would be like, okay, bro, go and output the value which is at names position. So first of all, this is going to have the value of 1. So it's going to go to names 1, it's going to output mass. Then next position, it's going to become 2. So it's going to output names 2. So it's going to output Musa. Then it's going to output names 3, which is Mustafa. And so on. It's going to output all the one till it becomes 6 and it's going to end. And that is how you basically output data in an 2D array. So this is just an example we did for students. We did a lot of example for the students who were registered with me in the May June session. Those taking the classes right now will also be aware. We used to basically do a lot of past paper questions too. Now, because of lack of time, we will not be able to look onto this, but you guys are having these notes of mine. If you don't, you can go to my website, or you can ask anyone from my website, or you can even go to my Instagram page, Code Catalyst underscore CS, and you can follow that. And of course, you can ask for the website, and the notes are basically in the bio. You can access those from there, and you can have a look at all these practice questions which we did. And if you, let's say, don't get anything, you can reach out to me later on. But that is how you basically make use of a 1D array. Now we will be basically starting off with a 2D array. But before starting off with a 2D array, I feel like there should be a 5 minutes break. So I'm going to have a 5 minutes break. You guys can drink water, but be back by 4:13. Break. Okay, everybody, don't leave the class. I will not be leaving the class. I'm also going to stay up here. You guys should also stay. Don't leave. But yeah, be back by 4:13 and we will be then restarting again. Till then, just go drink water and have a bit of chill. All right, guys, let's start off again from where we left to continue the content. So just give me a minute. All right, let's start off again, guys. Bismillahirrahmanirrahim. So let's continue from where we left. So we were discussing this concepts of what we call it arrays, right? So we're gonna continue. Let me just put my phone onto charging, and then we can start. So right now, 1D array seems to be a bit easy. The main challenge arises when we discuss the two-dimensional arrays, right? Those are the main things. 2D arrays are not easy. They are challenging. They are stuff which people don't understand. So we're going to see how do we generally use 2D arrays, and then we're going to understand the concepts behind them. So let's start off. Bismillahirrahmanirrahim. So what 2D array generally it is all about that it allows multiple rows and columns. The way we saw that the normal 1D arrays only have a single column, your 2D array now has rows and columns inside. Okay, so yeah, so it has rows alongside columns inside it. So it's when you have a scenario where you might want to store both the rows but also at the same time columns, like the way we generally saw in a 1D array, it was just like this. But let's say I want to extend it to something like this, where I might want to have rows, but also multiple columns, not only a single column. That is something which you do using a 2D array. So a 2D array, again, just like before, is going to have data of the same type. So like if I store string up here, this also needs to be string. That's the reason why I place these quotation marks around them. That if it's Mars as a string, this 65 is also going to be quotation marks to indicate that this is also a string. So if I do something like 192, this is not integer. This is basically a string. Remember this. This is a string. Okay. So how do you declare a 2D array? So it's sort of similar to the normal 1D array declaration. You write the keyword declare, you write the name of the array, and then after that, you specify that it's an array which has this dimension. What are the dimensions? You first and foremost tell the rows, and then you tell them the column. So you're like, okay, I need to have 1 to 5 rows. So you're going to create one single column first, the way we normally do. So you're going to have a 1 to 5 rows column, which means that there will be 5 rows. And then you're like, okay, I need to have 1 to 2 columns. So you need to have 1 to 5 rows, which means 5 rows, just the way normally we did like array 1 to 5, right? So this meant that there are going to be 5 rows. But now just additionally, we're going to add a comma and you're going to then specify how many columns do I need? 1:2, which means 2 columns. And then you specify the data type. Like for instance, if I have to specify a specific a student record array, which has like 6 rows and like 3 columns, I'm going to do it in a way that I'm going to write the whole thing and then I would be like array 1 to 6 to specify 6 rows and then 1 to 3 to specify 3 columns. Okay, and then I'm going to write the data type of string. Now, one important point here to understand is that when we used to talk about position, for the 1D array, it was pretty easy that I just did something like student position number 1. So I knew that because it was a 1D array, it was referring to position number 1 up here. But how will I find out the position up here? Am I talking about this? Am I talking about this? Am I talking about this or what? So when you talk about 2D arrays, you have two things. You have the rows and then you have the columns. In a 1D array, it was all about rows. We just said that, okay, row number 1, row number 2, row number 3. Up here, you also need to specify the column number. Are you talking about column number 2, column number 1, or what? So when we want to access the value in a 2D array, remember this short form of RC, remote control Okay, the same RC helicopter which was there in GTA Vice City, which did not allow us to enjoy our childhood because there was this one mission which was really, really challenging. Remember, guys, that was what we call as RC. But here, RC is basically row followed by column. RC basically refers to row followed by column. So if I want to access some specific array, the way I'm going to do it is that I'm going to write the name of the array, then I'm going to write the row, and then I'm going to write the column. So I would be like, okay, array, row, and column. For instance, if I want to access some value and I do student record 3, 2, this means go to row number 3, go to column number 2, and whatever the value is, grab that and put that in X. So how will I do that? I'm going to come to this array, student record. I'm going to go to row number 3, which means that I'm talking about this part. So I'm talking about this part. But what column do you want to go me to? Do you want to go take me to column number 1, or do you want to take me to column number 2? It says column number 2. So I'm going to go to column number 2 and boom. I see this 67. So this 67 as a string will then be extracted, and this will be then placed in the variable X. Likewise, if I want to output something, just like before, I'm going to write output, name of the array, student record, and then I'm going to specify the specific sort of the value. Do you want to go to row number 2, column number 1? So I'm going to go to row number 2, I'm going to go to column number 1, this name of Anas. This is going to be fetched out, and that will be then printed up here. So output student record of 2, 1, which is basically going to print Anas. Likewise, if I want to update a single value, the way you're going to do is that you're going to write the name of the array, like student record, then you're going to specify what position you want to go into. Like for instance, I want to specify updating this 67. How will I do that? We'll be like, okay, easy. Go to this arrays, student record, go to column number 2, go to row number 3, and whatever the value is, put 75 there. So I go to student record, I go to row number 3, I go to column number 2, I get this 67, and I replace this with a 75. So now that is how you basically generally access the data and generally put data inside it. Okay. Now, if I want to initialize a 2D array with zeros, let's say all the way with zeros, the way you're going to do is you're going to first and foremost take one column, and you're going to do this for the same column, you're going to set all the rows to 0. Then you're going to go to the second column, and then you're going to do the same for the second column. So the right way to doing this is that you make use of 2 loops. First, you say that, okay, I'm going to make use of a for loop, which is going to run for the 2 counters, for the 2 columns, column number 1, column number 2. So when you go for column number 1, then you need to go for each row, column number 1, row number 1, column number 1, row number 2, column number 1, row number 3, column number 1, row number 4, column number 1, row number 5. And for all of them, you need to set the value 0. So you're going to go for column number 1 to 2. Then for row number 1 to 5, you need to basically put 0 in all the positions. So like this will be 1 firstly, and this will be 1, 2. So you're going to go to student 1, 1, which is basically student 1, 1. You're going to put a 0 up here. Then you do next row number. So this becomes 2. So for the same column number, this is going to be now 2, this is going to be 1. So you go to row number 2, go to stay in column number 1. You put this as 0. Then you put this as 0. Then you put this as 0. Then you put this as 0. Once done, you do next column number. Now your column number becomes 2. So now you change this to 2. And again, this is 1, 2. So you do this, then this, then this, and so on. You see that you filled and initialized the entire 2-dimensional array with the value of 0. And that's how you basically fill a 2D array with the 0 values. So if ever in exam they give you a question to initialize a 2D array with some 0 values or with some empty values, you need to make use of exact same logic. Go with the column first and then go with the rows. So for column 1 to this, row 1 to 5, fill it with 0. Moving on, if I have to continue, this is one question which I would love to solve with you all. Let's say you need to initialize a 2D array that asks the user for marks. Suppose column 1 has student IDs which have been already initialized and the class size is 35. So like let's say there is a 2D array which you need to initialize, where you need to ask the user for marks and you need to put those marks up here. And it told us that the first column is basically storing the IDs of the students. So like student number 1, student number 2, 3, 4, and total there are 35 students. So how will you declare this array? It's not required for the question, by the way, but how do you declare it? Because it's going to ask for 35 students, this means that the class size is going to be of 35, which apparently means that it needs to start from 1 and it needs to go all the way till 35. Now there are two ways. Either your array is going to begin from 1 and it's going to go to 35, or in some questions you will also see that the array begins with 0. When it begins with 0, because your computer science also counts zeros to be a valid index, if something begins counting from 0, like I say that the first item is 0, like 0 key, then 1 key. So like when 0 is the first element, you go 1 less than that. Because if I count 5 and I'm like, okay, 0, 1, 2, 3, 4. So even though these are 5 fingers, counting from 0 means that I'm going to go till 1 less than that. So it's 0, 1, 2, 3, 4. I go till 4, not 5. But if I start with 1, 1, 2, 3, 4, 5, then I go till 5. So when you start counting from 0, you need to go 1 less than what's the maximum value. So this is just an example so that you are aware of how to go with zeros too. Otherwise, even if someone goes with 1 to 35, that's perfectly fine. But when you go with 1, you need to go till 35. When you go with 0, you need to go till 34. We know that the first column number 0, because everything is starting from 0, is storing the values of student IDs, and column number 1 is going to store the marks. So how do you declare it? You're going to be like, okay, declare the marks array, which is going to be of, what do we call it, 35 rows, starting from 0 all the way to 34 elements. And then there will be two columns. With the first column number 0, column number 1 will be the second. So two columns of integer. So then you need to basically say that, okay, bro, you need to, for the row number 0 to 34, because we have 34 rows starting from 0, you're first of all going to say, bro, enter marks for student ID. And then I might want to output this ID, which is stored up here. Like, let's say this ID would have been something like ID number 1. So I would be like, okay, enter marks for student ID and whatever the value is stored up here. So you go to the marks array, you go to the whatever row number you're currently at, and you grab the value which is at column number 1. Why do I grab column number 1 value? Because I know that the student IDs are basically stored in column number 1. So because it's stored in column number 1, you basically go to column number 1, you go to whatever the row is, and you're going to grab this value, and this is going to become something like enter marks for student ID 1. Then it's going to become enter marks for student ID 2, enter marks for student ID 3, and so on. It's going to move. And then every time you're basically going to input some marks, those marks are going to be inputted, and those marks are then going to be stored up here. So if I want to store some marks up here, this means I need to go to the array with the name of marks. And then I need to go to the position of column number 1 and row number 0. So I would be like, okay, go to marks, go to whatever row I'm at. I'm in row number 0. And then I need to go to column number 1. So in column number 1, I need to put the marks. But because I'm doing it for all these rows, rather than doing it individually, I created a for loop, right? So I would be like, okay, go to the marks 2D array, go to the position of row number, and there in column number 1, you need to store the marks. And then you go to the next row number, and you keep on doing this until you do it for all 35. So this is how you're going to store a specific two-dimensional array. And that's the same logic being used in the 15 marker. If they have to manipulate arrays, 2D arrays, where you might going to access data somehow, that data will be then used in these columns. These columns will be then modified. The value is going to be taken here and there. And just like this, you need to understand that whenever you solve a 15 marker, I always tell my students, it's really important that you make a diagram to understand that if you're putting some data up here, what is this position? What's the column value? What's the row value? Do I need to put 0 up here? Do I need to put a 1 up here? This point is really important for you all to understand when dealing with 2D arrays. We're going to do 2 other examples because 2D array is a bit challenging, so I want you all to fully understand it. Let's say there is this other question which says write a program that makes use of a 2D array, student marks, that stores the marks of an entire class alongside the ID, like column number 1 stores the ID, column number 2 stores the marks, and then calculate which student got the highest marks in the class of 50 kids. So just like before, it's the same one, but right now you're making use of the same chapter 7 concept which we studied that day in maximum, to calculate maximum score. I'm going to create two variables like maximum and ID. And remember, if you don't have space in exam and you might want to declare two variables in one line, you can also do it this way. You're going to be like, okay, declare max and ID as integer. So both max is an integer, ID is an integer. This is also one way of declaring variable in the same line if you don't have space. I'm going to initialize it with the value 0 and 0, and then I'm going to be making use of a loop from the first to 50. And I'm going to see that if the loop is basically in this, because the marks are stored in column number 2, I'd be like, okay, buddy, go from the first row to the 50th row, first to the 50th row. And for all of them, check if the score in the second column, if it's greater than maximum, put that score in the maximum variant. So if the student marks, go to the student marks array, go to whatever row you are talking about right now, go to column number 2, and whatever the score is there, if it's greater than max, put that score inside the max variable. And then put the student's ID, whoever scored the highest, in the ID variable. Now, if I want to access the ID, I know that the ID is accessed in column number 1, whereas the marks are stored in column number 2. So what's the difference? It's the same thing. The row number stays the same. Row number always stays the same for one student. So both this entire row is storing detail about the same student. Storing detail about the same student. But column number 1 talks about the ID. So when I put 1 up here, it's talking about the ID. When I put 2 up here, it's talking about the marks. And this detail is what you can find in a question. What's the ID and what's the mark? Read the question clearly and make a diagram like this, and you will understand what could be your ID and what could be your marks. And then this is going to continue, and at the end, you'll be like, okay, the student with the highest marks has an ID of this, and the highest marks are basically this. How do you output it? You put these quotation marks that it's a string. Then whenever you want to put some variable, you put a comma, name the variable. Then again, if you want to put a string, add a comma, write the string, again, comma, and the name of variable. And that is how you generally make use of two-dimensional arrays. So right now we have understood 2D arrays generally. Later on, if you might want to understand even more in great detail, now if you go and watch my 15 marker solution videos, I've uploaded 2 to 3 on my YouTube channel. We're going to even have more inshallah soon. But if you basically generally have a look at this, what do we call it? The 15 markers I've uploaded on my channel, you're going to see that, where do we need to uh, and then you're going to understand how to make use of it the right way. Mahat, can you tell me? I did not understand your question. Why do we need to initialize, and can we set row column both to 0 in one row column? Where are you talking about? What row column are you referring to? Yeah, just a minute, just a minute. Let me allow you to. Mahat. I'm gonna just open the chat box. Just let me know, okay? I won't be taking more questions, by the way, but this is just gonna be one question. Yeah, so you can send the question in the chat box. Say the first example. You're talking about this one, the question one? Yeah, so in this, why do we need to initialize the values? Okay, the one before. Okay. What's the name of my channel? It's Code Catalyst. I'm gonna send the link in the chat box too. You guys can just subscribe to it, and also at the same time, it's having a lot of useful stuff for you all. So you can just have a look at it, and inshallah, it's gonna be very helpful for all of you. Okay, so let me just send the link. By the way, by the end of this class, I should be having like 600 subscribers on my channel. Okay, I should be having 600 subscribers. That's really important. I've sent the link in the group, and I'm also going to share it up here. We just need like 10 more subscribers. So by the end the class ends, I need to have 600. So yeah, the first example. So the one before this. In this, why did we initialize it from 1 to 2 and 1 to 5? So what was your question? So why do we need to initialize the value? Where did we initialize the value? It's just a question, okay? Sometimes you are required to initialize. Like, what if the question says that you need to initialize the value? Like before, it's similar to saying that, okay, you might want to create something, and you tell me that at the start, if there is a program that calculates or stores the marks of all the students, and right now I've entered no one's marks inside it, then in that case, this means, right, that the marks of the entire class is 0 because I haven't entered anybody's scores. So whenever you create a program, you always have to initialize it with something. Sometimes the question asks you to initialize an array. So this is just a method to tell you how you can basically initialize it. And it's not necessary to initialize it with 0. It could be generally with anything, but this is just to tell you an example that if a question comes up to initialize something with the value 0, this is how you need to initialize it with the value 0. But generally, initialization is done using the value 0. It's because to indicate that, okay, I created something, it has nothing inside it, it is empty. To indicate that it is empty at this moment, we put value of 0 inside. Clear? Now is it clear, Mahat? Let me know in the chat box. Perfect. All right, that's great. We have covered up 1D, 2D arrays. Let's move on to now the complex concepts. We're going to be studying linear sets. Now, what's linear sets? So Linear search is basically that concept of your computer science where, like, let's say there is an array which has multiple names, and I want to find the name of some person. So if I have to find the name of some person in an array, how do I find it? So for that, we're going to go through a method known as linear search. So I'm just going to take an example, and in that, I'm going to just show you how this is done. So generally, the way you implement linear search is that you basically take the name from an array and you input some name and you compare it. If it is, you say person found. If it's not, you're like, okay, search again. So I'm going to be like, okay, input, or like for instance, I want to find the name of Anas in this array. So how will I do it? I'm going to make use of a loop that is going to go from the first counter all the way to the end. Okay, 0, 1, 2, 3. And I'm going to be like, okay, if the names at whatever the position is, if it is equal to Anas, you output that the person is from. If not, you go on to the next one. So it goes in a way, it comes up here, position number 0. This is Ramin. So if Ramin is equal to Anas, you output person found. Is Ramin equal to Anas? No, right? You move on. You go to Aliza. Is Aliza equal to Anas? No, you move on. It's Anas. Is Anas equal to Anas? Yes, it is. So you output person found. This concept where you're sort of finding some name within an array is known as linear search. But the problem with this code, which I just wrote, it is sort of a bit inefficient. Okay, it's a bit inefficient. So what we can do is that rather than, because why is it inefficient? Because let's say I find the name of Anas up here. It says output person found. Then it again does next count. It goes up there. It again checks, is Samraj equal to Anas? For no reason. Even though I did found Anas name, but it's still looking it. So it's wasting computer's precious power. So for that, we have an efficient code that works in a way, which is basically if I have this names up here, Maz, Varisha, and Rayan, and I like, let's say, want to see if I found the name or not, the code which is going to be implemented for a linear search is this. How does this work? So we basically have three variables. We have the name variable, we have the found variable, we have a count variable. We're going to be like, okay, first and foremost, have we found the name? No, we haven't found the name. So like, okay, set found to false. And then you're going to start the counting from position number 1. So there is a variable with the name of count. Because we are not making use of for loop, we need to use a count variable, which we need to initialize on our own. So that count variable will have the value 1 inside it. So I'm going to be like, okay, buddy, enter a name. So the person is going to enter the name. And then I'm going to make use of a repeat loop. I'm going to check if the name is equal to the array count position name. Like for instance, count has the value 1 right now. So if someone enters like Ali, if Ali is equal to Mars, how did I get Mars? Because I went to the array and the count had the value 1. So I come to Mars, I took this Mars, I compared it. If it is equal to it, you set found as true. If it's not, you increase the count value by 1. So now it's not equal, so the count value now becomes 2. And then you're like, okay, you need to keep on repeating this until either found is true or count is greater than 150. What does that mean? I'm going to come to that. So for instance, I find my name. Count value is 2. And I check that, okay, I've inputted Mars, and at position number 2, there is Mars. So because I found my name, and let's say this is like a very big array of 150 people, 150 people, do I need to check the entire array if I found the name of Mars? No, right? There is no need to search for the name of Mars when I found it at the first place. So when I've already found the name, the way I'm going to do is I'm going to change the found variable value to true. When I change it to true, the thing is, because I made use of this repeat loop is going to run until either when the found value is becoming true or when the count value is greater than 150. Count variable value is only going to become greater than 150 when it has checked the entire array. So if this array had 150 elements, 150 people name inside it, and let's say it checked all 150th one, and the last time it checks the 150th name, like if name is equal to the position of 150, if it is still not found, I'm going to be like, okay, 150 plus 1, it becomes as 151. So like this means that I've ended the array, I've checked the entire array, and the name has not been found. So this loop is going to stop when either I found the name, which is going to be denoted by the fact that the variable found's value is going to become true, or if the count variable value is greater than 150. When either of the condition becomes true, in that case, your loop is going to stop. Now, once the loop has stopped, I'm not sure whether the name has been found or has it ended because the variable count has a greater than 150. So in that case, I'm now going to be making use of an if statement. I'll be like, okay, if the variable found has the value true, this means that somewhere in the program, because I originally set it to be a false, this means somewhere in the program the name was found. So if it is found, this means output person found. Else, just say that the person was not found. And that is how you are going to be searching the name of a person efficiently using a linear search. Is this clear, everybody? Hi. Can you guys send some reaction like a thumbs up or something to see if it's clear? Perfect. That's good. That's good. All right, let's move on. So now we have studied what's linear search. Likewise, in your computer science exam, there's also one concept known as bubble sort. What's a bubble sort? A bubble sort is like sort of a method where you're required to arrange an array which might have some values ascending and descending wise. Okay. So for instance, you might want to just just a minute. When do we use the found variable? We use it whenever we might want to make use of a linear search. So whenever you might want to make use of a linear search, it's better to go with the found variable. Another question asked by one of the students, sir, when do we put an arrow and when do we put an equals to sign? You always put an arrow, okay? There is nothing like equals to sign. You always put an arrow. Only when you're declaring a constant, you put an equals to sign. Apart from that, you always put an arrow. Simple. We discussed this in chapter 7 too. Okay. So now back to the bubble sort concept. So what's the bubble sort concept? So in the bubble sort concept, it's important for you to understand that sometimes there might be an array which has values like this: 1, 8, 4, 12, 3. And I need to sort it ascending wise to make it 1, 3, 4, 8, 12. How will I do this? So for that, what we do is we implement a logic known as bubble sort. People and generally teachers, they just tell their students to memorize the code. I'm going to teach you guys one other method, which will ensure that your concepts are clear. Now, whenever you might want to make use of an bubble sort, let's say we have this example of 8, 1, 4, 12, 3, and I need to order it in ascending wise. So what I'm going to do is, how many number of variables do I have? I have 5 variables. So the way it's going to work is I'm going to compare two variables with each other to see that if one variable is greater than the other one, I'm going to swap them. Like compare 8 and 1. Is 8 greater than 1? Yes, it is. So I swap 1 with 8. So 1 comes up here, 8 comes up here. Then I compare 8 with 4. Is 8 greater than 4? Yes, it is. So 8 comes up here, 4 goes there. Then I compare 8 and 12. Is 8 greater than 12? No. We don't make any changes. 8 stays where it is, 12 stays where it is. And finally, we make change of 12 and comparison of 12 and 3. Is 12 greater than 3? Yes, it is. So I made 12 up here and I brought 3 up here. So when I do one set of this iteration, like one entire loop where I basically compare all the values with its corresponding ones, I see that one value is sorted. So I see that in this variable array 1, 4, 8, 3, 12, 12 is at the perfect position because 12 has to be the largest value. And I see that the most right hand side value at this point is the most largest one. So I see that one of the value is sorted. Now I'm again going to repeat the same thing, but because this time I know that this value is sorted, I'm just going to go till one less than what I was going previously. So previously I was going till the value 5. I was comparing all the 5 values. This time I know that one of it has been sorted, so I'm just going to compare these 4 values. So I'm going to ignore this 12. I'm just going to deal with these 4. So how will I do that? Again, compare 1 and 4. Is 1 greater than 4? No. So it stays the same, no difference. Compare 4 and 8. Is 4 greater than 8? Now, again, no difference. Compare 8 and 3. Is 8 greater than 3? Yes. So make the changes. Bring 8 there, bring 3 here. You make the change and it becomes something like this. And now you see that 8 is again at its perfect point. It's the second largest one. I don't need to compare these two. Why? Because I know that 12 is the largest one. And I said that rather than going till 5 now, just compare it with the fourth index. So 1, 2, 3, 4. So I've compared these 4 values, good to go. Now I know that these two are basically sorted. These 8 and 2 are basically perfectly sorted. Now I need to compare 1, 4, 3. Again, this time I'm going to just compare 3 elements. I'll be like, okay, compare 1 and 4. 1 and 4 bigger? No, says the same. 4 and 3? Yes, there is a difference. So I make a difference and I see that this 3 comes there, 4 goes there, and I get this 4 sorted too. So this 4 is also now sorted. So I'm only left with these two values to be sorted. And now I'm going to sort these two with the final one where I'm going to just check it with itself. N equals to, I'm going to check it. Is 1 greater than 3? No. So it stays the same. And I see that my values at this point are perfectly sorted. So that variable which I had at the start 8, 1, 4, 12, 3, it has been successfully converted into 1, 3, 4, 8, 12. And that's what bubble sort is. So you're sort of going to be comparing the value with the value next to it. So if let's say this is position number 1, if this is position number 1, I would be like, okay, compare this with position number 1 plus 1. So I would be like, okay, if this is whatever position, if this is 1, I want you to compare it with 1 plus 1 position, like compare it with position number 2. So I'm going to compare 1 and 3. Likewise, if I have to compare these two, I would be like, okay, if this is position number 3, compare it with 3 plus 1 position, or position number 4. So generally, when we do this in arrays, we do it in a way where I'm like, okay, array, count, and I'm going to compare it if it's greater than array, count plus 1. So I compare it with the next element next to it. So I compare this 4 with the one next to it. Now, how does this sorting work? If I have to sort of tell you, we basically say that there is values 1 has the position 6, values 2 has the position 4. Now, if I have to basically make this swap of making 4 up here and making 6 up here, a lot of you might have this one question in their mind and might say that, okay, it's pretty easy. I would be like, okay, go to values 1, and in values 1, you just put the value of values 2, and then you go to values 2, and you in values 2, you put the value of values 1. But let's try doing this. So if I do something like values 1, which is basically the first index, and in that I put the value of values 2, which is 4, I see that 4 comes up here. So I get 4 up here, and then I get 4 up here. And then in values 2, I put the value of values 1. But bro, at this point, values 1 is also 4. So I apparently am again putting 4 up here. So this 6 just got lost. So to sort an array, or to sort or swap two values, whether it's an array, variable, or whatsoever, whenever you want to swap some values, you always create a temporary variable. You're like, okay, buddy, first I'm going to store this temporary variable value in this temp value variable. Like for instance, I have these variables and I might want to swap this 4 and 3. Okay, so first I'm going to store this 4 in this temporary variable so that this temp will have the value of 4. Then in the first position, I'm going to put the value of the second. So this 3 is basically going to come up here. So it's basically going to become like 3, 3, 9, 11, 1. And then I would be like in variable 2, put the value which I placed in temp variable. So right now, this temp had the value which was previously of values 1, which was 4. So temp was equal to 4. So now this value of temp, which was 4, now that 4 is basically brought up here. And I see that this 3 is then replaced with a 4. And I get my sorted array as 3, 4, 9, 4, 1. And that is how you make the necessary swap. Now, if I come to the code part of it, the code is pretty much very easy. It's like literally very, very easy. What are we going to do? We sort of start from the very first index, like I have 6, 4, 2, 9, 5. So this is my first one. So my first number is position number 1. And how many numbers do I have? I have 5 numbers. So this is my maximum, like the last number is at position number 5. It's not indicating that the number is 5. It's indicating that the last number is at position 5 and the first number is at position number 1. So the way I'm going to swap it is that I would be like, first of all, setting a swap variable to false. And then I'm going to check. I'm going to set a loop that is going to run from the very first one, the way we did like up here. We're going to go from the very first one. And we're going to start from the position variable number 1 all the way to the last -1. Why did I do last -1? That's very important. A lot of people don't get this. I'm going to come to this later. But I'm going to go till the last one and I'm going to check that if the number count, like if number position number 1 is greater than number position +1, like count was 1, so 1 plus 1 is 2. So like is 6 greater than if 6 is greater than 4, in that case, in the temp one, you store the num count. So num had the value 1. So I see the value 6 is basically stored in temp. Then I see that in num count, I store the next value. So in this 6 valuable position, I bring the 4. So 4 comes up here. And then I say that in num count +1, I put the value of temporary. So I put the value of temporary in up here and I see that the 6 value comes up here. So I made the necessary swap the way I just taught. And then I set this swap variable to true. Okay, I set it to true. But now the question is, why did I go till last -1 and not last? People usually get confused with this. The reason is, the main logic behind this is that generally we compare this stuff in a way that we are like, okay, compare 3 and 3 plus 1. Now, if I have 5 elements in an array, I only have 5 elements. And I let's say that compare number 5 with 5 plus 1, which is 6. Is there any 6 up here? Is there any sixth value up here? No, right? There isn't. There isn't any sixth value. So for that reason, because there isn't any sixth value, when we do something like last plus one, it's going to give me an error. So for that reason, in a bubble sort, we never go to the extreme end. We always go to the last element minus one. So because even if it's like the last element, which is like four in this case, it's going to still compare it with the fifth one. How? It's going to be like, okay, if number count 4 is greater than number count 4 plus 1, which is 5. So this fifth last one is still considered. But if I do something like 5 up here, then it's going to compare it with 6. And we don't have anything like a 6 up here. For that reason, it's going to cause an error. So when you might want to make use of a for loop, you always set it to 1 less than the maximum number. And then we made this swap as true. Now you might have this one question, sir, why did you make this swap as one true? I made it swap because I need to check that when will I end, right? Is this array even sorted or not? So for that, there is one thing. I saw that every time I make use of this one swap, one iteration, like one specific thing starting from the very start, I saw that at the start I was checking it for 5 elements. But when I did it once, I knew that one element was sorted. So this means I need to next time go till 4. So like if my last value at this find was 5, right now my last is 1 less than that. So when writing the code, you're also going to do the exact same thing that you once you do the next count, which means that you're going to do it for all the values. So you're going to swap all of them. And then at the end, you're going to get this 9, which is perfectly fine. And then I would be like, okay, now I need to just look upon these 4 values. So I'm going to change this 5 to 4. For that, I'm going to reduce this last variable value by 1. So I did last minus 1. So now I'm just going to compare these 4 values. And this thing is going to again go back. It's going to repeat. And the same thing is going to happen until either two things happens. If let's say the swap variable value is false, if the value is false, and I have something like this, I have something like 2, 3, 4. Okay, let's see. And I have to compare the values. And I check that is the number 2, if this value 2 is greater than 3, is it greater? No, right? It's not greater. So this thing just goes on. You go to the next count, you check 3 and 4. Is 3 greater than 4? No, right? It's not greater. So you go back and you check up again. Let's say we have a 5 up here too. Is 4 greater than 5? No, again, it's not greater. So you go back. So when we have a scenario like this, when we basically have a scenario like this, where rather than when like sort of your array is already sorted and you might want to stop, how will you get to know? That is possible by this swap variable which we created up here. So if the value of swap stays false, and like I go through the entire array and nowhere there is a situation where a swap has to happen, this means that my array is already in order. So like if already my array is like in 2, 3, 4, and the variable swap value is only going to become true when there is a necessary swap, but I go through the entire array and I see that there has been no swap at all. This indicates, and this basically tells me that, buddy, your array is already sorted. So you need to keep on repeating until if your swap variable value stays false till the end of the program. Like it was set at false at the end, and then even at the end, if it did not get changed to true and it stays as false, this means that your array was already sorted. There was no need to even change anything. So in that case, you should just stop. Or the second way is that your last value becomes 1. So the last value becoming 1 is the same case where I was just discussing up here, that you keep on sorting one by one. This was 4, then it became 3, then it became 2. And finally, the moment this became 1, I know that this entire thing was basically sorted. So either when it becomes reduced to 1 or when the variable swap has the value of false, in either of those two cases, you are basically going to be required to stop swapping the array, and you would be like, okay, the array has already been swapped. So up here, one other important point is that sometimes in exam, you will see the word not swap. So they might say until not swap. So until not swap is the same as saying that swap has the value of false. And that is the whole algorithm of a bubble sort, which you all should be aware of. So I'm going to open up the chat box and I want you all to just let me know, is this clear or not? I won't be answering very basic sort of questions, but yeah. Clear, right? Perfect. That's so great. Sir, you the real arrays. Real arrays. Sir, please explain the second line now. Ali, I'm gonna answer that later on, guys. Don't send me a message. I'm only arrange. Okay, I'm gonna good question, Ali. Good question. All right. Okay, okay. Why last equals to 1 and not equals to 0? Because definitely when you go to the last item, let's say all the other stuff has been sorted, let's say everything has been sorted, then what will you compare this one with? If I know all of this is sorted, I'm just having one element left, what will I compare this one with? Nothing, right? So there is no need to go to 0. So the moment you come to the value of 1, you're like, okay, I have everything else sorted and I'm left individually, so this means I'm also obviously at the correct position. Second point is that why did I do last being assigned with last minus first? It's the same thing like up here. What did we do up here when we were basically done with sorting every time? I said that the number of values which I'm going to now compare, it's going to be one less than previous. So like if I was comparing 5, the next time I compared only 4, then I just compared 3, these 3. Then the next time I just compared these 2. And finally, I was left with 1. So every time once I was making use of a for loop, every for loop when it ended, like every time this whole thing iteration happened, I was like, okay, now I'm going to check 1 less than the maximum. So like if previously I was looking up till 5, now I like not 5, it's going to be 5 minus 1. Like I was going till 4. Now I'm going to go till 3. So I'm just going to grab these 3 characters, these 4, sorry. Then the next time I do, I'm just going to grab these 3. Then I'm going to just grab these 2. Eventually, I'm just going to have one value, and that one value will tell me that I've completed it. Now, one point here to note is that this is something which I did for ascending. Now, if a question comes and asks you to do bubble sort pseudocode, but for descending one, the main difference between ascending and descending is that in ascending, you compare something like, we say that if it's something like 7, 3, and 2, and you compare it like, is 7 greater than 3? Then you make it something like 3 and 7. 2, and then you're like, is this greater? Then you do 3 to 7. This is how we do it in ascending order, right? But if it's descending, you do the same thing but in a different way. But if it's something like 2, 7, 3, you check, is this 2 less than 7? Is this 2 less than 7? If it is less, up here we were doing if this 7 is greater than 3, right? We were checking if it's greater. But up here, we're going to check if it's less than 7. If it's less than 7, then make this one. Then make it something like this. Then, is this 2 less than 3? Yes, make the swap. So when it's descending order, the only difference comes up here in this condition. So if it's descending rather than this being ascending one, you're going to just change this to descending. So if descending, change this to less than 7. So this is the shortcut. The whole code is same, but if it's greater than basically means that you're talking about ascending, and when it's less than, it basically means you're talking about descending. Clear now, everybody? All right, perfect. Let's move on now. So we have studied the important concepts, the important questions, and everything which is there out in your syllabus. Right now, we're going to be jumping into the final parts of chapter number 8, which is basically functions and procedures. So what are functions? What are procedures? We're going to see all of those in great detail right now. Okay, so functions and procedures are basically things which were introduced in the world of computer science. Because let's say I might be doing something again and again, again and again, but I don't want to, like, let's say, keep on repeating because it's wasting my energy. For instance, to give you an example, what I can do is that, let's say I have a package coming up, okay, and every time a package comes up, I need to basically say, hello, what's up, welcome, man. Okay, every time a package guy comes up, I will like, hello, what's up, man, welcome. So if I'm writing a program for this, definitely I'm going to be outputting it this way: output hello, output what's up, output welcome. Now imagine I have to get like 100 packages every day. Does that mean that while making the code for it, I need to write output hello, output what's up, output welcome 100 times? It's going to be challenging, right? And someone of you might say that then make use of for loop. But again, I might not be required to make use of these statements at once. Like I won't be like, okay, hello, what's up, welcome, hello, what's up, welcome, hello, what's up, welcome, hello, what's up. I would be like, okay, hello, what's up, welcome. Then I might be doing some other thing. And then immediately there is a need, hello, what's up, welcome, again doing hello, what's up, welcome. So now if I have to repeat the same set of code again and again, what I can do is I can make use of a function or a procedure, where what I can do is I can basically combine this set of code, I can make a package out of it, and I can basically call this package afterwards whenever I want. So I can create a package, And that package could then be called anywhere, wherever I want. So this package creation is what we are going to be studying today, which is known as functions and procedures. So your computer science has this one principle of DRY, which means don't repeat yourself. If there is some place where you're repeating yourself, you can become more efficient. Like for instance, what's a procedure? So a procedure is basically a type of thing which does some sort of, which is basically a set of programming statements which are grouped together under a single name. And that could be performed, a call to perform the task at any time. So like I created a procedure with the name of greet. So if that greet, just the way up here, I created a package, right, with the name of greet. I would be like, okay, whenever I call this greet procedure, it should automatically output hello, it should automatically output WhatsApp, it should automatically output welcome without me writing this again and again. So for instance, how will I be making use of a procedure? So like, for instance, I might want to create a procedure. The correct syntax or the way to declare it is that you're going to write the keyword procedure, you're going to write the name of it, you're going to write the code up here, and then you'll be writing end procedure. An example for the greeting one was up here. You might write something like procedure greet, and then you'll be like output hello, output welcome, output what's up, and then you're going to do end procedure. So what's happening? We just sort of created a package. Now, next time, if I might want to say that a delivery guy came up and I want to output these three things, I will not be writing these three statements. I'm just going to be like call procedure. So to basically implement what's happening within a procedure, I'm going to be like call with the name of the procedure name. So call greet. So my computer would understand that, okay, this is trying to call a procedure, go to that procedure, it's going to come up here and it's going to run all these statements one by one. Now, even though this may seem small, but what if I say that for every delivery guy that's coming up, I need to output like 10 lines of code. So writing 10 lines of code for every delivery guy is very challenging. So I create one procedure with the name of greet, which does all of that. And every time a person comes up, I'm just going to call the procedure. So call greet. So remember that a procedure, if I want to use the procedure somewhere, it's always being called. So I'm always going to do call procedure name. And this is what I basically will be making use of when making use of a procedure. So a procedure allows me to basically simplify my program by not repeating the code again and again, but rather creating a package which basically knows what to do. And then I can basically just call that package and it is going to do whatever code I told it to do. For instance, I want to create a mathematical formula which does this thing. So I might want to make a formula like this. And I want to create a procedure which will be like, okay, bro, if I do something like math 3, it should basically put this 3 inside this and it should output some answer for me. So rather than doing it like, okay, input 3 and then doing output 3 square and blah, blah, plus 2 and all that stuff, what we do is we're going to make a procedure for it. Let's say procedure math formula, which is going to be taking number as an integer parameter. So when I assign some value to a procedure or a function, which it's taking as an input, like we saw that when we had a length function previously in today's class, the length function was taking some variable name, right? This variable which it is taking as an input, that is what we call as a parameter. That is what we call as a parameter. So if I call something like that as a parameter, this parameter up here is basically an input to a procedure. So for instance, up here, I'm making use of this number variable. What's the value of this number variable? Where does that come from? So this value of number basically comes up from this parameter up here. So the user will be writing something like math formula 3 within the brackets. So this 3 is basically the value of number, and number is going to have the data type of integer. So when I'm creating a data procedure, I'm going to specify the data type next to it. Okay, so integer. So now when I say that the value of number is 3, anywhere within the procedure, wherever we have this number being used in the code, it's being replaced with the value of 3. So like for instance, we created a variable with the name of answer, which has the value of integer. I'm now going to create that in the answer variable, you store the value of number into number plus 2. So if number was 3, you do 3 into 3 plus 2, which is basically 11. And then you're going to outputting the answer. Remember, procedure always outputs. Procedure cannot return a value. It could not be you cannot do something like X with call procedure or like call math formula. You cannot do something like this. So you cannot sort of output what do you call it, store the value in some variable. We need to output the value directly within it. This thing which I just did, where you assign the value into some what do we call it, a variable, this is known as returning. So this process where this is going to return some valuable value to the x variable is known as return. Okay, so now this is how you create a procedure. So now next time I might want to make use of a math formula, I will not be writing this code again. I'm just going to do call math formula 7. So this 7 is basically going to replace this number. Everywhere we have this number, it's going to change it with 7, and it's going to give me an answer. It's going to output the answer, and boom. Now, if I had to do it for 7 and 5 separately, I would have been written 1, 2, 3. I would have to write 6 lines of code. But right now, I'm just writing 2 lines of code and I'm done. So when I do call math formula, it's going to just output 49 plus 2, 51. So I get 51. And when I do call math formula 25, it's going to calculate 5 square, which is 25 plus 2, 27. I get that on my screen. That is how you generally make use of procedure. Main point, procedure will never return a value. Whenever you want to output some value within it, you're going to make use of the output function, or you're going to make use of the call. So if you want to call, or when you want to make use of a procedure to be executed, you're always going to execute it using the call function or call operator. So we're going to write call followed by math formula, and it's going to do something for you. That's what a procedure is all about. So if ever in exam they ask you to create a procedure, you're going to create a procedure this way, and it's basically going to do something, and then at the end you might be asked to call it. So you're going to call it this way. So for instance, you need to create a procedure that takes n as a parameter and outputs high n times. So you're going to create a procedure where if I say something like, okay, welcome 7, so it should say hi 7 times. It should say hi 7 times. So how will I do that? I'm going to create a welcome procedure. I'm going to say procedure keyword. This is basically a header, this first line. And in that, by the way, this needs to be capital. I made it in lowercase one, but this has to be in capital one. You're going to write the name, and then this is my parameter. So I'm going to say that the parameter will be n, and it's going to be of the data type integer. Then for count 1 to the whatever value of n is, we're going to output high. So if it's the value of n is 7, it's going to run from 1 to 7, and it's going to output high every day. So when I do call welcome 7, it's basically going to output high 7 times. And then I'm going to be like in and procedure. And then next time, maybe I might want to input something. So the way you're going to use it, you're going to take some input for a value. If you, let's say, might want to make use of value, and you're going to do call welcome val. So this means that whatever the value the user inputted, it's basically going to replace this up here. So if it was 5 inputted, it's similar to saying call welcome val is equal to call welcome 5. Clear? And but if I have to do it separately one by one for all of them, then it would have taken a lot of code. So we don't want to spend ourselves wasting time on that. So because of our procedure, we just declare it once. And now wherever in program I need to repeat the same set of code anywhere again, I am just going to be basically calling the procedure, and it will execute the same code for me. This is some practice session we conducted during our May-June 26 session for the students. Every Saturday, Sunday, we used to have a session. I used to make them do difficult sort of questions. So you can have a look at this. It's for 1D and 2D array, and it will help you with understanding the concepts. Okay, perfect. Is this clear with the sticker or like a, what do you call, reaction emoji? Quickly. Good. Damn, guys, I'm done. Literally 2 hours and 20 minutes. Okay, 2 hours, 20 minutes. Crazy. Well, let's move on. We are close to the end. Likewise, we have something known as a function. Now, what's a function? A function is just like a parameter procedure. It's pretty much very identical to procedure. It has the same task. It helps us save time by reducing the chances of repeating the same code again and again. Like rather than if I have to make the same equation, I'm just going to make a function. It groups a set of codes, like there is a set of code repeating again and again. I'm going to group all of them under a single name, and then I can later on call that code again using just by calling the function. But one important point here to note is that a function never calls itself. Okay, procedure always calls itself. Function has one thing that it returns. What do we mean by the term return? Returns mean that when I do something like a variable x being assigned the value of 3 plus 2. So this 3 plus 2, whatever the value of this is, it is being returned into x. So the value is basically returned, which also could mean that it's basically assigned. Okay, so if I have a function and a function has some value, that value is basically assigned to some variable. Okay, so when I say, or when generally it's being stated that a function returns a value, this basically means that it assigns a value to a variable. Okay, and how does this work? So for a function to be created, it's pretty much similar to how we generally create a procedure. You're gonna write the name of a function, you're going to write its name, then you're going to specify the parameter alongside its data type, and then you will tell the computer program that what will be its return data. Because it's always going to return something, we need to tell them what's the return data type going to be. And then I'm going to write the code, and then of course it's going to return some value. Wow, let me create an example and then you'll understand. We have this length function, right? This is a function. So this length function, it's basically going to take some variable x and it's going to calculate some value. How many characters? Character count, right? It's going to calculate some character count for. When it calculates that character count for me, we all are well aware that I just don't write like length x. I always do something like y and I put the value of this inside this y. We always do something like this, right? Length, and in that length, you need to put the value. We always do something like this. Why do we do something like this? Ever wondered? Because this length is a function and its value could not be directly output. The value does not get output directly. It generates a value and that value is basically returned. So the value which this program generates, whatever the final answer is, which it needs to output, that value is basically returned. So that value is returned, and then that value returning basically means that it's stored in a variable like length. So you could have not done something like this for a procedure. So if you did something like length and then you write something like greet, but this is like a procedure, this is wrong. Why? Because procedure cannot return, but a function can return. Because a function can return, we say that it can assign the value to something. Can assign a value to something. So a function, like for instance, procedure was outputting the answer. Rather than saying outputting answer, when we create a function, we say that it's going to return the answer. So for a function, it's always going to be return answer, which means that it's going to assign the value, the final answer value, to some variable. Like for instance, previously we did something like call math formula 7. So it was outputting the value, right? It was outputting that output is 49 plus 2, 51. Right now, if I do something like 2, this is going to calculate the value like 2 squared plus 2, which is going to be 6, but it's not going to output it. It's going to return it. By returning, I mean it's going to put it back in a variable. And now I'm going to output the variable. So I'll be like, okay, output x. Now the value of x is going to be 6 at this point, which is going to be the answer calculated from here. And that's going to be outputted. So the difference between procedure and function does not lie with the fact that it's basically something different. No. The only difference is that a function can assign a value to a variable because it can return. A procedure never returns value, which means its value cannot be even assigned to anything. That's the main difference between your procedure and function. Like for instance, take this example. You need to create a function that converts Fahrenheit temperature into Celsius scale temperature. What's the equation that's given? That whatever the temperature is, you minus that 32 from it, and you divide that by 1.8 to get the temperature in Celsius. So if I have to create a function with the name of Celsius, I know that if I have to divide something with 1.8, my final answer could be something like 180.7, 36.2, 35.9. The final answer could be in decimal point. So I'll be like, okay, buddy, the function Celsius temperature will take a parameter with the name of temperature, which will have a decimal value input. So the data type is going to be real. And of course, when it returns me and give me some value, that can also be real. So what I'm going to do is I'm basically going to create a variable in the net, which is with the name of answer. And this answer variable is going to have the data type of real. Okay. So if it's having the data type of real, I'm going to be like, okay, create and calculate the answer first. So answer being this. So it's going to create some answer and I'm going to be like, okay, return this answer. So when I return this answer and I might want to make use of it in a program, I'm going to be like, okay, go to the value. And in that value, you need to make use of the function Celsius 180.7. So this is going to calculate a value. But because that is being returned, that value is stored in the value variable up here. But if I did the same thing for a procedure, a procedure cannot return. The way we did return up here, a procedure is going to output the value. So if a procedure outputs a value and I can only do something like call Celsius 140. But if I do something like value being assigned with call Celsius 140 or 160, that's wrong. This is something which only a function can do. But a function cannot do something like this. Now, if I write something like Celsius and let's say Celsius 140, but this is a function. This is a function. If this is a function, it makes no sense. It's not going to output something. If it's not returning a value to something, it's of no use. Okay, it's of no use. Just a minute. So it's of no use at all. So whenever you have a function, you're always going to assign the value to some variable. Whenever you have a procedure, it's going to be directly called. This is really important for you all to understand. Also, one other thing is you can do something like output, and then you might do Celsius. If Celsius is a function, this is fine. Okay, this is fine. But if you do something like output, call Celsius, let's say Celsius now is a procedure, that's wrong. Okay, so this is also something you should be aware of, that how you can basically, when can you output something and when can you not output something. So if it's a function, you can output it this way. If it's a procedure, you cannot do it this way. You just need to write call, check balance. And that's the main difference between procedure and functions. Is this clear, everybody? Yes or no in the chat box. These are some other examples if you might want to have a look at. But yeah, I'm going to open the chat box right now and I want you all to let me know, is this clear or not? Perfect. That's great to know. All right. So procedure outputs on their own, but function. No, Sarah. You basically, whenever we have a procedure, we make them output the value inside. A function can also output, like if someone does something like output answer, that's not wrong. But that's not the purpose of a function. A function returns a value. Because procedure cannot return a value, it's of no use. It's of no use, right? So whenever we make a procedure, we always output the value within it. So if a question comes up asking you to create a procedure, it's going to do something. It cannot return some value. It cannot do something. Either it's going to output some value or it's going to do some task. Simple. So a function returns a value and a procedure doesn't. Javeri, you can go for the chemistry class, which is left with file handling. If you want to revise that, you can watch the recording later on. Otherwise, you're done. Okay. So we're outputting a function output the code inside it or the answer. It's going to output this answer, this answer, which is going to be basically returned. This answer, which is going to return. Whatever I write after the return keyword, if I output this Celsius, it's basically going to be returning this answer value. Sir, parameter. What parameter? What parameter? So this is my parameter, guys. This thing is my parameter. Uzafa, what were you explicitly asking about the parameter? All right, I guess it was answered. Let's move on. The chat box will, by the way, open Uzafa. Sir, parameters पहले से input होते हैं. Yeah. So these parameters, you always input it. Okay, so we declare it and then you basically always before and you specify the parameter up here. So like if I'm calculating Celsius, I need to put the value up here. इसके बगैर नहीं हो सकता. Okay. All right. One other small thing which a lot of people are not aware of is sometimes you're going to see that a variable is being declared within a function and a procedure. So if a variable is declared within a procedure or a function, like the way I declared this answer up here, this is basically a local variable. Why is it a local variable? Because it is declared within a procedure or a function. If something is declared within a procedure or within a function, it is only allowed to be used within this specific boundary. So now if I do something like output answer up here, this will not run. Why? Your computer would be like, I don't understand what's happening. What are you trying to do? I don't understand what you're trying to do. Why? Because this answer variable was declared and only correct within this range. Only within this range. So such a variable which is declared within a function or within a procedure and is only used within that specific boundary is known as a local variable. A variable which is declared outside, like normally anywhere could be used, like for instance, I declare something like up here, declare x to be as an integer. Now this x could be used anywhere. Maybe even if I do like plus x up here, my computer will still understand it. If something is generated at the top which could be used anywhere in that program, and even within the function, outside the procedure, outside the function, like even if I do like output x or anything like that, that specific type of variable is known as a global variable. So you should be just generally aware of the concept that local variable is the one when you declare it within a specific procedure or function and it is only allowed to be used within that. Whereas a global variable is the one which could be used everywhere, wherever you might want to make use of it, right? And it's basically something which could be used anywhere and could be outputted. But a local variable cannot be used everywhere. It has a specific boundary. Without that, you cannot make use of it. Clear? Let's move on. So this is also some important point which I wanted you all to be clarified upon. But yeah, moving on, the last concept in your syllabus is the file handling one, which is that let's say we have seen how computers can store data, how it could be processed. But what if I say that rather than taking an input from the user, you need to take the input from some text file? So if you have to take some input from the text file, how do you do that? For that, the concept of file handling was introduced where computer programs will like always store the data. Like either I might read the data or maybe I have to write some data, right? So if I have to store the data somewhere again and again and maybe open it up, how will I be storing that data? So for that, I'm going to be making use of a file. So why do we need file handling? It's because if I, let's say, wrote an essay and I don't store that essay on some file and I turn off the computer, I return it on, it's going to delete the whole data because everything is in the RAM. It's not in the secondary storage. So what we do is we basically make use of some file handling function, which allows us to open a file, allows us to read a file, allows us to write data into file. Okay, you should be aware that the questions in your syllabus are going to be very easy. They do not include anything like append. They do not include anything like end of file. None of those stuff are in your syllabus. Okay, and how do you basically work upon this? It's basically pretty much very straightforward. There are just three functions which are there in your syllabus. One is opening the file. The second is reading the file. And then the third one is basically writing the data into the file. So you have four main commands in your syllabus. The first one comes out to be as the open file one. The second one comes out to be as the close file one. The third one is the read file. And finally, the last one is the write file one. The way it works is we're going to make a flow diagram first and foremost. So whenever you want to open up a file, whenever you might want to make use of a file, the right way to doing it is that you're going to open a file, then you're going to either read it, then you're going to write it, and then you're going to close the file. These are the four main commands which will be eventually used when writing the file, which I'm just going to show to you all using this example we have up here. So for instance, you need to write a program that reads the data in a specific file with the name of students.txt. So there is a file with the name of students.txt, which you need to open up, and then you need to basically read the data from it. So the right way to doing it is that this variable, this student.txt, this needs to be first and foremost stored in some variable. Like I might create a variable with the name of my file. It's going to store this string value, which is going to be of students.txt. And then of course, I would also be storing my final answer, like whatever data is up here, like this 95. If I want to store this 95 in a sentence, I would also need a sentence variable with that too. So the way I'm going to do is I'm going to create two variables. One will be with the name of my file. The second will be with the name of sentence. Both have to be a string value. And then I'm going to be basically saying that the file which I need to open is my file, and that has the value of student.txt. So I assigned the name of the variable value up here. So whatever the name of the file is, I assigned that to my file. And now I'm going to open it up. How do I open it up? I would be like, okay, open file, name of my file for the purpose of read. Or I can also do it the same way where I can say open file student.txt for read. Okay, so you basically can. So it basically can, what do we call it? Just a minute, guys. So yeah, so basically what you can do is you can either assign the name of the string up here to a variable, and then you can open that, or you can directly open up that string too. Both of them are perfectly fine. So these are two methods, but you just saw that what I did was I opened the file, but I specified that, okay, I need to open the file with the name of this for the purpose of reading it or writing it. So when I want to read the data, when I want to access the data, when I want to fetch the data out from a file, I'm going to go with reading. When I want to write some data into an empty file, I'm going to make use of the write function. Then if I, let's say, want to read it, I would be like, okay, read file sentence. What this does is it's basically going to go to that my file. It's going to go to my file. And in that my file, there will be some sentence. There's going to be some sentence. Okay. One sentence. It's only going to have one sentence. Remember, according to your syllabus, according to your, what do we call it, level, it's only going to have one sentence. It's going to read that one sentence. And then whatever the value is, that value will be stored in the variable which name is written after the comma. So when I write comma sentence, this means that whatever value has been read through the read file command, store that value in the sentence row. That's why I created a sentence variable up here. Now, if I declare something like line, in most of the cases, there is something like a line. So if I have a line like this and I do read file line, so what this will do is it's going to read one line and it's basically going to store the data of that in that line variable. And then, of course, I might want to output the data which I've read. So I'm just going to do output sentence. And just the way I mentioned up here, whenever you open up a file and then read it and then write it or whatever you might want to do with it, always close the file. There is one mark for closing the file. How do you close the file? You just write close file, bracket, my file. That is how you basically open a file for reading. How to basically read data out of it. Then likewise, if you might want to output the data, if you, let's say, might want to output the data, how do you output the data? That's also pretty much very easy. It's not that complex. It's just going to be, again, creating two variables. This time, because you want to write something into an empty file which has nothing inside it, it's like totally empty. You're going to create a my file which is going to have some empty name. Like for instance, this, they might give you a question, right? In the question, there will be like, there is a file with the name of empty.txt, which you need to basically modify. So I'm going to put this empty.txt into my file. And then I'm going to first open the file, but for the purpose of writing it. So I'm going to say open file, my file for writing. Then I would be like, okay, output, enter a statement. So you're going to input some line, which you might want to put up here. Like for instance, I write Mars. And then to write this up here, you're going to write the write file command, comma, text line. So it's going to take whatever the value is in text line and it's going to apply the write file function on it, allowing it to be written up here. So in your syllabus, you're only required to write on one line. In AS level, you're going to have multiple lines to be read and written from. If you watch some other teachers' video, they might even make you force on doing those extra concepts. But please, guys, this is your syllabus. It clearly mentions that you are only required to read items single one. So not required for multiple lines. So if you're taught that EOF thingy and loops within them, that's not required at your level. They won't be tested. That is something which you're going to inshallah study if anybody of you opts for AS computer science, inshallah. But that is how you generally make use of writing function. So that is how you read and that is how you write. That is the most you need to know. So for instance, this is one question which I did, like take an input for marks and store it in an empty file with the name finalgrades.txt. So you're going to create a my file with the finalgrade.txt. Now you're going to open that file for the purpose of write. You're going to input marks. You're going to write those marks into the file and you're going to close it up. And that's the whole logic. Apart from that, these are some other examples which I did. You can also look up onto them later on. But of course, the last part of the syllabus is this one theoretical question which is generally tested in most of the cases, where they say like, how do you create a maintainable program? So to create a maintainable program, remember your 15 markers should always be maintained. Okay. So my teacher made us practice loop writing into a file. No, that's not relevant. You know, that's the same thing. That is something which you're going to study when you go to AS level. I had the syllabus attached for the same reason. You always make use of loop when you have multiple items. You make use of loops when you have multiple items. Read the syllabus, including read and write single items of data. Unfortunately, the teachers here right now, they are not even aware. They themselves don't know whether it's included or not. That's the reason why I recommend every one of you to please go read the syllabus on your own, so that you yourself are aware that what's testing, what's not being tested, and that you're fully efficient with what could be tested. If you don't know this, then there's no benefit, right? You understand the point. So it's really important that you always read the syllabus on your own. Coming to the main point about maintaining a program, remember your 15 marker should be maintained, which means that when you're making use of a 15 marker, always look out to this, because in your 15 markers, there are 6 marks for this. So 6 marks are for ensuring that your program is maintained. What do I mean that a program is maintained? This means that your program should make use of meaningful identifiers, which means that if I'm creating a variable, if I'm creating a procedure, if I'm creating a function, if I'm creating a constant, some array, the name should explain what it is doing. So if there is a variable which is storing the age of someone, it should have the name age being assigned with 12. It should not be something like XY being assigned with 12. That's not correct. You got to do age being assigned with 12. Now, if I do something like XY, do you understand what this XY is storing? Is it some product? Is it some plus minus? Is it age? I don't know. But when I say age being assigned with 12, yeah, it clicks my brain that, okay, it's storing age. So in your 15 marker, you're going to have marks for this. Remember, in your 15 markers, I don't know if your school teachers ever taught you this, but your paper pattern is divided into assessment objective 2 and assessment objective 3. Assessment objective 2 has 9 marks, assessment objective 3 has 6 marks. This is for the coding part, and this is for good programming techniques. Like if you made use of correct meaningful identifiers, you divided the program into modules, you made comments, you're going to get 6 marks. Like literally, if most of your code is incorrect, you can still get that 6 marks. Imagine. And then if you make some sort of correct logic, you can get up to 10. So it's not that difficult, guys. People just emphasize upon it. It's not that challenging. It's pretty much very straightforward. People don't understand it. So one thing, whenever you're writing code, always try to make use of meaningful identifiers, stuff that explains the purpose of it. Secondly, whenever you're making code and you want to make something meaningful, you need to divide it into modules, which means that rather than doing something like writing one whole code, or like the way I just explained, that rather than doing one thing, which is basically, what do we call it? क्या कहते हैं? Rather than repeating the same set of code again and again, what you can do is you can divide it into functions and procedures the way we just saw. So always try to ensure that when you're making sure that your program is maintained, try to convert or divide it into functions and procedures. Likewise, always try to comment your code. Especially for the 15 marker, you're going to have marks in them. You need to comment your entire code. There are like always add a comment after every 4 to 5 lines. Like for instance, you're making use of a for loop, so just add a comment. How do you add a comment? You basically add the slash, which is a sign for the comment being started in the pseudocode. So you add the slash and you say initializing array with the value 0. So yeah, so that is how you basically make use of comments. And if you want to have a look at a sample 15 marker, there are multiple sample 15 markers uploaded on my YouTube channel. One is up here, 215 marker practice. Apart from this, there are a few others uploaded too. You can also look on to them, and then you're going to understand how to solve a 15 marker in great detail. Apart from that, there is this trace table concept, which is basically one way of how you could input the values, then you do some actions upon them, and it's basically going to give you some output. So this is something which basically is a byproduct of whatever course content we studied. But this officially marks the end of our content for chapter number 7 and chapter number 8. Congratulations, everybody. So you guys can ask the questions. You guys can ask the questions. You guys can ask the questions. सर 2 दिन में P2 हो जाएगा, पता नहीं. Sir, where can I find your notes? So you can find my notes on my website. You can ask for my website in the group, and someone can share it. Is it written like this? Write file, my file text. Yep, it's written like this. You see, written. Let me read. You see, right? No, sorry. You open the file first, and then you write file, comma text, or like the file, the data which you need to write. So write file, comma text. Will you have classes before the board? Well, what do you guys say? Do we have another marathon class? Should we have another marathon class? Maybe one marathon class for 15 marker, maybe 1 or 2 marathon classes for the entire paper 1 course revision, Maybe entire P1 course revision. It's going to be a bit crazy though, but we can, right? And of course, what if we do a few 15 markers practice session too? Sir, how do we conduct flow charts? Heather, the recording for this has been uploaded on my YouTube channel. Go to chapter 7, programming masterclass number 1. And in that, I have basically explained how do you basically create flow charts. So you can just vote that and it's going to be clarified. We did it in the last class. Sir, input for function are taken outside the function, then put in the function where it applies the step. Exactly. Yeah. Correct. You're correct. So you basically, the way function works is that a function always makes use of some parameter, right? So you need to put give it some value. So this value needs to be taken input externally. So you might say input value, and then this value will be used as a parameter up here. Oh, this question is from last one, but we call procedure in Pseudocode. But how do we write for functions in Pseudocode? So you just it returns a value. It never outputs something. So there are two ways. One way is that you output it. So output, let's say function 2. So this is one way. Or the second way is that you assign the value to something like x being assigned with the value of, let's say, function 2, and then you output x. That is another way of doing it. Clear? So where can I find questions of structure charts? Structure charts is pretty much very rarely tested, so it's not that commonly available. But still, you can look up. You can ask in the group. Someone can share that. So what you guys can do is you can join my WhatsApp community group. For those who aren't a part of it, do one thing: open up Instagram, go to @code catalyst underscore CS, or you can go to my YouTube channel, Code Catalyst. You can find the recording and stuff there. From there, you can join my WhatsApp group. And just to let you all know, okay, so you can just, if for those who might not have the link and they want to get added, you can reach out to me on my number. However, just note that I'm going to add you to group. My DMs at this point are literally spammed. I'm unable to respond in DMs. Try to, what do we call it, ask the questions in the group. And if there is something not clear, just let me know then. Say, so you can text me on my number, but I usually don't respond quick. So I have, even at this point, 238 unresponded DMs. So yeah, we will be inshallah arranging a class. Awais, don't worry. Okay, we will arrange it. But this is it for today. So is output declared for function or only return? So is output declared for function? Anushe, I feel like you need a whole class on functions and procedure because it's not clear. Let me tell you what to do. So do one thing. Go to my YouTube channel. Okay. So come up here, come to my YouTube channel. And up here, you're going to find a lot of resources. In this, you need to go to playlists. And in playlists, you need to basically come up to this part of where do we have chapter number 8 somewhere in here. So you're going to have chapter number 8 up here. You're going to click on this. And then in this, you're going to go down and watch this functions and procedure video of 1.5 hour, and also this 1 hour. Watch these two videos and then you will fully understand what we are trying to, because in this I've done multiple examples too. So for anyone, this was a pretty summarized recap, right? But if you want a detailed recap of what everything, I have uploaded the entire chapter 7, uploaded the entire chapter 8 recording for free for you all to master up the whole content. So if anybody still has some questions in their mind or some topic is still not clear, you can just open up this channel on mine. I have uploaded everything in great detail. So you can just go watch those and you'll be very much, inshallah, good to go. So that's it for today then, everybody. Take a second. So when's the next class? I don't know. Let's see. Kuch pata nahi hai. But that is it for today, everybody. It was lovely having the class, and I hope it was helpful. If it was helpful, I would appreciate if you could drop a feedback in my DM. If it was helpful, seriously, and if you might want to share your review about it, you can. But yeah, inshallah, we're gonna have more sessions. Follow my Instagram page. Remember me in your prayers. I myself am a student. I had to prepare for my exams, but no, I've just spent 3 hours teaching you all today. But I hope it was helpful for you all. Take care, everybody. With this, I'm signing off. Allah Hafiz. See you guys, inshallah, in the next class. Take care. Allah Hafiz. Bye bye. Allah Hafiz.